Welcome back, guys, for another Flat Earth debate. If you saw last week, myself and the amazing MC Toon took on Howard George Stirrup, and there was obviously a miscommunication with the format, and Howard didn't really get to go over all the points on the topics that he wanted to touch on. So he contacted me, and we've agreed for him to come back, and we're going to go over point by point. He's sent me some videos to go over, and we're just going to do that. I'm going to respond to his points. I know a lot of you like to, see the Flat Earthers present evidence, but I think this is going to be a more of explaining the problems Howard has with the globe model, because as Howard says, he's not a flat earther, more of a globe skeptic. So we're going to go over some of the reasons why he appears to be a globe skeptic. Howard, hello, welcome back to the channel. How are you doing?
Hello, Craig, and thank you for having me back.
No worries.
And I'm looking forward to getting into this skepticism.
Who's your little friend there?
This is Smalley.
Smalley, the brains of the operation.
She's 20 years old.
That's impressive for a cat. Is she an indoor or an outdoor cat?
Oh, she's a bit of both.
Right, so she's in cat years, she's 20. That works out about 96 in cat years, if you age it equivalent. I've got two 17-year-old girls, and they're about 87. So that's doing very well for a cat. Impressive. Right.
Thank you.
Okay, so let's just get into this. Everyone knows who you are. Don't need to go through all the introductions. I'm sure they've seen you plenty. Just want to say thank you to everyone for joining. Howard has also agreed to answer questions at the end. So let's see how this goes. If you've got any questions, then feel free to super chat me or message me on Discord or tag me on Twitter or something. Send smoke signal, homing pigeon, some way. We'll read the super chats first and answer questions on there, and then see if we can move on to any others. So obviously, I appreciate any super chats you get. It's massively thanked. Right, Howard, do you just want to do a brief introduction of why you have globe skepticism, or do you just want to get into the points?
I suppose it's worth just mentioning, I appreciate that you have addressed me as a globe skeptic and not a flat earther, because when I first came across the idea that the globe might be a lie and that space exploration might be a scam, I did name myself a flat earther. I went and brought a t-shirt saying flat earth, and I suppose a few weeks or maybe months down the line, I realized that I'd left one belief system and joined another. And thanks to Harry from Edinburgh for his activism called John Smith's Globe Lie, I realized it was better to focus on skepticism instead of preaching beliefs. So we don't claim to know the answers, but we do have lots of questions, lots of doubt. And we think we've got lots of evidence to support our skepticism. So I'm really happy to be back and to be talking about skepticism and not being labelled a flat earther, as that isn't my burden of proof. I'm just interested in, as I say, getting closer to the truth via reduction. So if we can reduce the false variables, even if we're left with more questions, that suits me fine, as long as we're not being indoctrinated with things that we can prove are false.
Okay, so do you have the same skepticism for the flat Earth?
I wouldn't say the same, because I actually see more logic in the Earth being level and stationary than I do it being round and spinning and orbiting and all this stuff that we've all been taught throughout our lives. But I do see that there's a few problems with the general flat Earth model. I agree that you shouldn't be able to look south and see the Southern Cross rotating around what looks like a center point. We might not be able to see the Southern Pole star, but I believe that the Southern Cross is close and it goes around a focal point or a fixed point, which we assume is the south, and that you can see that from South Africa, Australia, South America. So yeah, the flat Earth model has that conundrum, and one or two other things that might not add up very well. But apart from those 2 or 3 conundrums, I feel like there's a lot more conundrums with the globe model.
Okay. Do you accept that some of your skepticism is based on, and I don't mean this in an offensive way, but is based on an ignorance of basic physics?
Not really, because it's, if I was on my own in this, then maybe. But because there's what appears to be millions of people around the world, and it seems to be getting more and more people, then I don't think it really depends on my ignorance or my misunderstanding so much, because there's a lot of educated and well-informed people. Some are physics teachers, some are some are people that have even worked in math, engineering, so that architecture, so that there's all sorts of professionals now that are joining the skepticism side. And I feel like the evidence is getting bigger and bigger for us. There's more and more cases and more reasons to become skeptical, I think. Otherwise, it's strange that every year there seems to be more flat earthers and globe skeptics. Even though technology is improving, it seems weird that we're going back.
Well, we are definitely going back with flat Earth. That is correct, but I don't think the flat Earth movement is growing. It's pretty much stagnated, and the amount of emails I get daily saying that they've left the flat Earth. But anyway, that was just a couple of questions that I had. I just hope that you can level the same skepticism towards both sides, because despite what flat earthers and people like yourself think, I am a skeptic myself. Of course I am. I'm a man of science. I've studied physics. I've got a degree in physics. I've got a degree in engineering. I have the tools to be skeptic, and I've tested the world and come to the conclusion from the tests that I've done myself that the world is in fact a rotating globe. That's what all the evidence would suggest when you actually tested it. But let's get to your points, right? So your first point is about Orion. Yeah.
Not necessarily just Orion. Orion's just one constellation that I recognise. It's an easy one to point out, and I've been blessed to be able to observe it nearly all through the whole year. I think there's just 3 months of the year where it's going above me in the daytime, so obviously you can't see it in the daytime. But apart from those 3 months, I can see Orion passing the same path in the sky.
And you see that as an issue?
Definitely.
I mean, have you looked into what we would expect to see on a rotating globe? Have you used any software that models, the solar system and what you can see throughout the year? Have you actually done any investigation into whether that particular query that you have is possible with the model that we follow?
Well, that's why I'm here now, because I've been looking at that cartoon behind us, or should I say, on the screen.
The CGI, yeah, I made that myself.
Good, because I'm looking at it when the Earth is on one side, nighttime is looking away from the sun. Where am I? So night time's that way. But then 6 months later, you're on the other side of the sun. Night time's now looking the other way, away from the sun. So if we're looking in two different directions, 6 months apart, I don't think we should see the same constellation, and I definitely don't think if we could see the constellation looking the opposite way, that it should cross the exact same path in the sky at the same angle. You know, the whole constellation stood upright, and it's crossing the same path in the sky. I've made a video to help others follow.
Well, let's have a look at that video. You talk us through that, and then I'll show you why it's wrong.
That'd be great.
Okay, so can you demonstrate how a star constellation like Orion can be seen 6 months later, and also how it can follow the exact same path in the sky? Yeah, I can. And we'll get to that.
If we're facing the opposite direction, being on the opposite side of the sun. So Orion's a great example because it's pretty much above the equator. So it's not like Polaris or the Big Dipper, where you could expect everyone to see it from the northern hemisphere.
A quick correction on what I said last month. I said the wrong last week. Sorry, I said the wrong thing. I said that Orion was closer to Polaris. I was wrong. I was thinking of a different. It is relatively close to the equator, but luckily we have models that can show that, and we'll go over that in a sec. But let's. So what this is showing.
Thank you for your honesty. So this is just showing an analemma which the sun makes over a year and the moon makes over a month. It's where you take a photo at the same time of day or the same time of night of the moon over a month or the sun over a year, and you'll see it makes a figure 8. And this could be expected on the heliocentric solar system and the globe model. But it could also be expected on a flat Earth or a concave Earth, or who knows what dimension Earth really is. But my point is, if Earth's tilted, could you just go back a little bit and pause on that image? It'll come back on, I think. Yeah, brilliant. So we can see that Earth is tilted 23.4 degrees, which if you take that off a 90-degree right angle, leaves 66.6 degrees. But that could just be a coincidence, I get that.
The average is actually 23.5 because it fluctuates.
Yeah, but my point being that we're technically looking, let's just say, downwards if north was up. I know that there's no up and down in your model, but we could say that we're pointing slightly down when we're in the December solstice, and we're pointing up at night time in the June solstice. So we're tilted slightly down at one time of year, we're tilting technically slightly up, and we're completely looking the opposite direction. And as we can see the star trails on the left bottom corner, that's what we see over a night. Well, if you could find Orion in that circle of star trails, you'd find that Orion still crosses the exact same circle. It's no difference 6 months later, 9 months later, which I think's more than peculiar. If we can just play the video on.
I'm playing it now.
Thank you. So here we can see what we'd expect to see on the bottom left corner. At one time a year, we'd be looking at one set of constellations, and another time a year, we'd be looking at a different set of constellations, as we're supposed to be going around the sun, and the sun's going around the Milky Way. But as we can see in the top right corner, we actually see the same stars, even though we're technically looking in opposite directions. And again, the star trails as the top left corner shows they still follow the same path in the sky throughout the whole year, just at different times of night. And this is what we're told to believe in, that the sun's shooting around the Milky Way, the Earth and other planets are all following it round the Milky Way. And this isn't to scale. It looks a bit silly, but if you actually drew this to scale, it'd look even more silly if the planet
to be honest, Howard, there's so much wrong with that graphic that I could do an entire video on that spinning vortex thing of why it's wrong. But anyway,
I'd like to see that cartoon to scale, because I'm quite sure that it'd look even more ridiculous.
It wouldn't look anything like that because they haven't got anything right about the motion or relative speeds or anything. But anyway, right. So what we're going to do is we're going to go to a model, Howard, and we're going to actually see if what we're seeing is what we're supposed to see. So let me just get this up. Desktop capture. Okay, so we're gonna go to Earth. So this is now. So let's have a look for where Orion is. Well, Orion's down there, so is there anywhere on Earth right now where we would be able to see it? Right, so we can't really see Orion now from where we are. So at this point in the year, we can't actually see it. So we definitely can't see it all of the time.
Yeah, there's 3 months of the year where it's above us in the daytime. That goes for every constellation. There's always 2 to 3 months where it'll be above us in the day sky.
All right, let's go backwards a little bit and see where it goes. So this is during the day. We wouldn't be able to see it. Let's go back 6 months, shall we? So. How do I change the date? Sorry, give me 1 second. I'll get the date. Okay, right. So let's go back 6 months. December. And let's find Orion now. Right, so there's the Orion's Nebula now. So we definitely can't see it all of the time. So we can only see it approximately 9 months of the year. Would you agree with that?
Yeah.
All right. Well, let's go out and have a look at Earth. And see where Orion's Nebula is compared to Earth from the outside. Alright, so where's Orion's Nebula? Let's have a look. Orion star system. Right, Orion constellation. So there's Earth and there's Orion relative to it over there. Okay, so let's go out where we could see it. So these are the relative positions when you're looking at what we call the celestial sphere. So Earth is there, Orion's over here. So let's move time forward 6 months. So your point is that right now, at this point, we shouldn't be able to see Orion. And you're right. At this point on the Earth, as we demonstrated, we can't see Orion. But all of the times we can see Orion matches with the model. So if this is where Orion is relative to Earth, then seeing it 9 months of the year actually makes complete sense, right? Because you'd be able to see it like, right, let's say when you're here, right? So we can see it now relative to Earth at the night because, you know, night, this will be just as night is starting relative to Earth at this point. So let's say we could start to see it now, and then as we go throughout the year, we can still see it, we can still see it, and then it would get to about this point, about 6 months later, where it's now at the other time. It's rather than being at the beginning of night, it's at the end of night that we can see it, and then as Earth moves over here, we now can't see it, and we're at the 3 months of the year where you can't see Orion. So that actually, seeing it about 9 months of the year, which is what we see in reality, matches the model of what we say.
I could agree. Sorry, can you still hear me?
Yeah, we can hear you.
Wait there, I've lost Say something again.
Testing, testing.
Oh dear. You can hear me, yeah?
Yes.
Oh, good, good. It's come back. Sorry, someone called me. Hopefully they won't call back.
That's right.
Right, so what I was saying was, I could take this graphic and say, oh, okay, I can understand why we'd see it late at night, one time a year, middle of the night, 3 months later, and early in the morning before sunrise. I get that. But what I can't seem to get my head around is why it crosses the same... Sorry, you still there?
Yeah, we're here.
I'm ever so sorry. I might have to answer the phone call if she calls back and explain that I'm busy.
That's okay.
So yeah, what I'm trying to get over is that it crosses the same path in the sky and Orion's still stood upright at the same angle in relation to where I'm looking at him. I don't think that the model can explain that, because just before you go, try and answer this. You do agree that the sun makes a figure 8 over a year and the moon makes a figure 8 over a month called an analemma.
Yeah. Those are to do with the fact that the Earth... Yeah, that's because the Earth's tilt is relative to the position of the sun. So when we are at this point, the Earth could be tilting towards the sun, the northern hemisphere towards it, but then 6 months later it's tilting away because the tilt... the direction of the tilt doesn't change relative to the sun. So as the Earth rotates and also on its own axis and also rotates around the sun, that would naturally make what you're looking at do a figure of 8 over the year as your tilt changes relative to, the position of the sun, or stays the same relative to the position of the sun. So seeing that is what we expect. And the same with the moon, because the moon rotates around the Earth orbits around the Earth once every 28 days. That is also happening with the fact that the Earth is tilting and rotating around its own axis. So naturally what we're going to see would form a figure 8 in the sky. That matches the model. Let's go into Earth and have a look at what we see from the night sky.
Do you see my point here? So we agree that you would expect, what do you call it, parallax. You would expect parallax, as we see with the moon, as we see with the sun. But we don't get any parallax. We don't get any figure 8s. We don't get any figure 4s. We don't get any 9s. We don't get nothing.
There is actually stellar parallax, but it's a lot less because they're a lot further away. It's the same as if you're driving past a bunch of stuff. The stuff closer to you seems to move faster and further than the stuff further away from you. It's the same with the stars. There is parallax, but it's really hard to notice because it's really small because it's so far away. I mean, the distance that Orion is away from us compared to Earth and the sun, it's millions of times more, So the parallax is going to be hardly noticeable, but when you use the right equipment, extremely accurate telescopes and stuff, you can actually see that there is a lot of stellar parallax.
I disagree, and I'll tell you why. If we were talking about Polaris, the North Star, or the Big Dipper, or the Southern Cross, then I could see your logic that it's just too far away to notice such a tiny difference. But when we're talking about Orion, which is technically above the equator, like the sun and the moon are technically above the equator most of the time, we should expect some kind of figure 8 or maybe even some other figures like we see with the sun and the moon.
Certainly, that's the point. I mean, any parallax we do see is going to be millions of times smaller than than what we experience with stuff closer to us. That's how it works. And there is wobbles to the stars throughout the year. That is a thing that happens, especially the North Star. That's one it's most noticeable with because it's at the center. You can see that it actually wobbles throughout the year because our axis of rotation also wobbles. But any parallax, any movement like that is going to be really, really hard to see because it's so far away.
Well, I think we should get on to the next point because that's pretty much what I want to talk about in the next point.
Okay, but do you agree that
our
our model explains being able to see it, though? How that isn't an issue?
I agree that being able to see the constellation Orion might be possible. I'd need to spend a bit more time looking at the angles of what you were showing me. Maybe for 9 months. 6 months more likely. 9 months seems a bit difficult, but maybe because of the scale of things. But I still can't get my head around why I see it pass the same path in the sky at the same angle. There is no parallax in my opinion, and I really don't think that there is any parallax in any of the constellations, because
I can send you lots of information about stellar parallax, Harold. It's a well-known and observed phenomenon, and not just recently. You know, it's been observed and studied for hundreds of years. As we get the ability to be more accurate of our observations, we can notice it more and more. But stellar parallax has been noticed by scientists and astronomers for hundreds of years.
Well,
and well documented as well.
You know about the Georgia Guidestones? Those 8 stone tablets that they put up saying keep humanity under 500 million.
Yeah, a bunch of crazy nonsense on them. But it's got the...
nature.
So it's got a circle that when you align it with north, you can see Polaris through it, all right? But here's the interesting thing. When that was set up, it wasn't actually set up to look at Polaris. It was set up to look at the north celestial rotation point. When that was set up, if you aligned it directly with north, Polaris was not right in the middle. It was actually up to the side. And since the 80s, since that was erected, Polaris has moved more to the middle of that circle. Because that circle is not set up to look at Polaris. It's set up to look at the north rotation point, which Polaris is currently drifting towards. Because it's not right in the middle. It's currently moving towards the middle and will move past it. But the Georgia Guidestones are an excellent way to tell that Polaris has actually shifted at least a tiny amount since the 1980s.
I don't know, because as an ex-Freemason, Polaris could be the all-seeing eye, because it's the most high.
Wow.
Just 1 second.
Yeah?
Sorry.
Polaris may be the all-seeing eye because it's the most high. Oh, he did just say that, didn't he? Hello, guys, in the chat. How you doing? Oh, Prof. Phil Bell, how you doing, my friend? Clive Wells, another professor. How you doing? Love to see the smart people here. Marcus Dresden, Adrenochrome Slurper. I see the Flat Earther Steel post there. Says NASA technology today is far more advanced than it was in the 60s, yet they can't use technology today to go back to the moon. You obviously haven't heard of the Artemis Project Steel Purse. Go and have a look. You sorted, Howard? Yeah,
I've told her to stop calling.
Okay, right. So, I would advise downloading Solar System Scope, the program that I was using, and having a look at what it depicts and what our model should be able to see. I'll also send you details on stellar parallax, and we also have records of Polaris moving over time, especially sailors have documented it extensively. In 900 AD, sailors traveling in the North Sea described the north celestial point of rotation as a dark spot void of any stars, because at that point Polaris was nowhere near it.
This is going to look pretty dumb on screen, but if Polaris is there, yeah, it doesn't matter how far away it is, it's over there. So if I'm looking this direction, but it's over there, I shouldn't see it.
Well, and Polaris is directly above us. So
no, I'm sorry, I'm back on about Orion, because that's my best point, because if Orion is above the equator, like the sun and the moon are generally above the equator, then we should see at least a figure 8 over a year, or half of a figure 8, except for when Polaris is in the daytime.
Well, again, anything that you see like that is going to be tiny, 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 tiny to our eyes. And there is movements of the stars throughout the years. There is stellar parallax. That does actually happen. And again, I can send you all the information about that. But as the model that I just used showed, seeing Orion through 9 months of the year, it makes sense. When you first start to see it, it's going to be towards the the beginning of night as sun goes down, and then 9 months later you're going to be able to see it just as the sun's coming up, and then for 3 months of the year you're not going to be able to see it at all, and that matches what we should based on the positions of the stars relative to our solar system. That's what we expect.
So, like I say, it's much easier if I had a graphics like you have, so maybe I will download it so that I can come back and prove my point better. But just for example, when you were on that program and you were saying, look, now you'd see it at the start of night, that would be, let's just pretend, looking left at your night sky, yeah? And then 9 months later, you're like, look, now it would be at the very end of night, just before sunrise. You would have to look far right in the night sky to catch it. So no matter how far something's away, if something's that way, it's still going to be that way if it's really far away.
But remember that Earth's a sphere, so we've got a 360-degree view, and even if something's over there and we're here, as the Earth rotates, we're going to start to be able to see it. Just as if we rotate in here and sun's going down, we're going to be able to just see it. But then 6 months later, as the sun's coming up, we're going to be able to just see it. That's what our model expects to happen. It's hard to show you what I mean with my hands, but honestly, the best thing to do is Howard, download that program. All right, I understand you're skeptical, right? But I believe that your skepticism is ignorance, and I don't mean that in a nasty way. I just mean you haven't actually looked at the things you need to look at to get rid of that skepticism, because skepticism in general is not a bad thing. Don't just believe any shit you're told. Look it up yourself. But that involves actually looking at what we expect our model to do, fully understanding what our model says is possible and comparing that to reality, which is something I don't think you've done.
I just feel like because you're so well versed and educated on these things, you're missing the simplicity of this. If we have to look at the start of night at one time of year because it's going to disappear, and then 9 months later we have to look at the very end of night just before the sunrise, then that means, like your diagram showed, we would be looking at a different angle. So if we're looking at it from a different angle, it should cross a different path in the sky.
No, because the angle is still relative to the tilt of the Earth. The angle isn't going to change. The position of the constellation of Orion relative to Earth's tilt, an axis of rotation, that's never going to change. So the angle relative to the Earth as it's rotating around the star is always going to be the same. There is going to be wobble with the Earth's natural wobble, which is what we see, and stellar parallax that we expect.
So I'm looking downwards away from the sun, and then 6 months later I'm on the other side of the sun, and now I'm looking up in the completely different direction. There should be a lot more parallax. There should be some noticeable parallax, even with the naked eye.
There is noticeable. No, not just to say it should be noticeable with the naked eye isn't factual. You need to actually see what it should be. You're just saying this is a classic straw man, Howard. You're saying, well, I say it should be this and it doesn't, therefore the Earth's not a globe. But that's not what our model says is the case. Our model says the opposite. Our model says that the angle should stay relatively the same because the axis of rotation and Earth's tilt doesn't change relative to the position of the stars.
I could agree with the Polaris North Star because we're always pointed north no matter what time of year. But when we're talking about the equator, we're talking about the exact opposite directions. Upwards at one time of year, downwards at the other time of year. I'll try and make a graphic model to explain it better. But I feel like the cartoon memes I made should explain it simple enough. But I think if we move on to the next point, because it's still about the stars and it's also about the wobble that you keep mentioning.
Right. Okay. All right. Fair enough.
We
I do
can
hope
touch
you
back
look.
on
You know,
this.
I do hope you actually look into these things because our model says that it's possible, and that's the most important thing.
And you can email me a link to this software, and I can.
Yeah, it's just called Solar System Scope. It's amazing.
I'll email you for it later or
Yeah.
tomorrow if you forgot.
Right. So point 2, globe skepticism. Can you provide any evidence to support the claim that all the stars are moving and that every 6 to 14 years Earth's wobble 0.5115 meters east of west off its general direction of drift? Sorry, what? What do you mean?
Well, you're saying that every 6 to 14 years, the wobble of Earth causes the North Pole to drift between 0.5 meter to 1.5 meters from its.
Yeah,
from its
and the
point.
position of Polaris is recorded. We've got almanacs that can show that happens throughout time.
Well, if that is the video playing, yeah.
Oh, sorry, I'll pause it there just so you could explain the
It's
title.
okay. If that was true, how come we still see the same zodiac constellations as
We
the
literally don't.
Egyptians, the Aztecs, the Mayans, the Chinese?
But
All of
we,
the ancients that carved in stone showed us the same 88 constellations as we see now. Scorpio still has claws. Aquarius is still carrying water. He hasn't dropped any. Orion, with his belt, he hasn't got
Harry,
any
we don't.
fatter or thinner. You know, he's not twisting around. You're not checking. He's not asking you if his ass looks big in this. So
Howard,
they're all still in the
we
same
don't.
position.
That's the
and
thing.
it's figured.
The zodiacs have actually changed. You know, recently we had to add a new zodiac and change the zodiac, and there's parts of constellations that have moved to other constellations. You know, this is all recorded throughout history. The stars are relatively the same, but they have changed position as much as we expect them to. I mean, we've got records of the stars moving. You know,
Well,
the
I've
main thing
seen
to all right.
records
Here's the main
of
thing to
things-
understand. Right, all of the stars that we see in the night sky with our naked eye, and even with most telescopes, they're really close to us in galactic terms. You know, they're a tiny portion of the galaxy that is, compared to the size of the galaxy, really quite close to us. And that portion of the galaxy, with all of the stars that we can see, is moving around the center of the galaxy with us. So the positions of those stars relative to us isn't going to change that much. It does change slightly, but the amount that we expect it to, it takes like 250,000 years or something for the galaxy to do one rotation, right? So, you know, for the stars in the sky to do a 360-degree turn, it's going to take 250,000 years. But over the course of the past few thousand years of human civilization, the stars' positions will barely have changed because they're all moving with us, relative to us. But they have changed slightly. And it's recorded. mctoon.net/Polaris has many examples of historical almanacs that sailors have used to chart the changing positions of stars throughout the years. Because sailors use the stars for navigation. It's called celestial navigation. You know, I've done it myself as a sailor. I've used the sextant to figure out a path and actually travel. And, you know, using the position of the stars is extremely important. But the position of the stars changes. So we have to chart the positions, the changing position of the stars, so that we can correct the things that we use for measurements. So that we know that, oh, this means that we're this far away because that angle is this much. We have to chart that the stars have changed to be able to accurately do things like celestial navigation. And Howard, they have changed the amount that we expect them to.
Well, if you don't mind, keep playing that video.
Yeah.
Because I've got stone carved zodiacs from thousands of years ago on the ceiling of the Dendera complex in Egypt, and many others like the Mayans and the Aztec calendars that were supposedly thousands of years ago, and they say that the stars haven't changed and that Polaris, as we can see, if you can pause this bit, Polaris was known as the North Star in all ancient cultures that used the Big Dipper constellation to determine what season it was, because there's 4 seasons: spring, summer, autumn, winter, and it can be really useful to know what season you're in and what season's coming up if you're into agriculture and also raising animals, and you've got to move animals from one place to another.
Okay.
So all these ancient cultures knew that the swastika was an important part. It was like the hands on the world clock, telling us what season we're in.
So like I said, the positions of the stars are what we expect, and there has been slight movements. You know, they're not exactly as they were thousands of years ago. They're relatively the same. These basic carvings that show us basic positions are still going to more or less match up. But Polaris shifting backwards and forwards across the celestial, you know, point of rotation is what we expect. You know, it's moved away from it and it's moved towards it. And as the wobble progresses, it's going to move further and further away from it. And that, you know, and that's what it shows. But we have records of the literal changing position of Polaris. In fact, modern telescopes that are used for celestial navigation, they actually have markings on them so that they know that if you're using this in this year, Polaris is going to be exactly in one position, and if you use it in 10 years later, Polaris is going to be in a slightly different position. It's marked on telescopes so that you can do, you know, observations of the stars. Yes, these ancient things are going to more or less still match up with what they saw when they looked in the sky. But that is because, like I said, all of the stars that we see in the night sky, including Polaris, are moving around the center of the galaxy with us at the same speed, keeping their relative distances to us pretty much the same.
Why is that? I mean, I could understand that the planets stay around the sun because of the magical gravity force that the sun
Nothing magic about
has,
gravity,
like,
Howard.
Huh?
Nothing magic about gravity, but gravity is the answer. The solar system, our solar system, and all of the stars are orbiting the center of the galaxy because there is a supermassive black hole called Sagittarius A that exerts an immense gravitational pull that makes all of the stars in the galaxy rotate around it.
Sounds cool, but I've got stone carvings and loads of artifacts from all over the world that suggest that Polaris has been and always will be the North Star. And you've just got some reports.
I've got actual documents that people have used to be able to navigate the oceans. And like I said, I said, Howard, ancient people would have seen Polaris as roughly in the middle, right? It would have been pretty much the middle, but it's been shifting backwards and forwards all of the time. You know, it is over, you know, since the 80s, since the Georgia Guidestones were erected, the position of Polaris in that circle has changed. It is recorded as changing. Sailors have had to use that to say that it's changed. All these symbols, I'm not going to keep it up because it's Nazi, but all of these symbols, right, they still make sense, right? They still make sense today because the position of the stars is relatively the same. Not exactly the same, but relatively the same, almost the same, because they're all moving throughout the galaxy with us. And that's the thing, right? This is what our model says. So to be able to understand why this is happening, you have to understand why our model says that is the case.
I've got 2 little points before I forget. And maybe you're not going to agree with me, but maybe you can at least see the logic and agree on that it's a lot easier to fake some documents, some reports, than it is to fake some artifacts. So I'm going to stick with the artifacts.
But again, the reports and the artifacts don't contradict each other. You know, the stars are almost in the same positions, but they have shifted slightly enough that it would affect navigation. All right? These aren't just little reports. These are almanacs from thousands and thousands of different sailing groups around the world in different languages that all match up from throughout history, showing that the positions of the stars change. We can measure today, year to year, that the positions of the stars are not exactly the same. That's the thing. The
Have
Georgia
you got anything
Guidestone, like I
in
said, shows that.
I disagree, but have you got anything in stone that supports your theory? Because my evidence is in stone and metal artifacts from all over the world.
But again, your evidence doesn't
reports from
contradict mine.
Stevens-
Howard, this is what you're ignoring. Your evidence of those symbols and stone carvings of the stars and stuff does not contradict mine. It just shows that the stars would have been in almost the same position, right? Those stone carvings, they do not have the exact positions of the stars to the millimeters. They were not accurate. They show where the stars roughly were thousands of years ago, and thousands of years ago, the stars would have roughly been in the same position. Not exactly, roughly. Yeah, because all of the stars that we see in the night sky are relatively close to us and moving through the galaxy with us at the same speed. All of them.
So when someone's racing someone on a race course, the car on the inside is able to turn quicker than the car on the outside, yeah?
Yeah, if they're maintaining the same rotational speed, then the car on the outside would have to have a faster tangential speed, and that's the case with the galaxy's like a disk that is spinning. The entire galaxy is spinning at a 250,000 years for 360 degrees. So the outside of the galaxy has a faster tangential speed than the inside of the galaxy. Just like the Earth, as it's spinning, the equator has a faster tangential speed than as you go further towards the poles, where the poles have zero. That's what happens with spinning things. But we are on a little arm on the western spiral arm of the galaxy, and we're on a tiny bit of that arm towards the outer edge of it. The entire thing is moving around the center of the galaxy. And all of the stars that we see in the night sky are just a tiny, tiny portion of the western spiral arm of the Milky Way galaxy.
So the closest star is 20 trillion miles away.
250 million years, not 250,000. I'm wrong. It's even more. It's 250 million years, possibly.
That's all years and light years. But I'm saying in physical distance, supposedly the closest star is over 20 trillion miles away from Earth. Yeah.
I don't know the exact miles. I know that it's I can't remember the name of the star right now.
My point being,
it's 4.3 light years away.
Cool. If the closest star is 20 trillion miles away, and then there's a star behind it that's maybe 30 or 40 trillion miles away, that's going to have to travel a lot faster to be following us around the Milky Way.
Yeah,
like you're saying, it has to go
that's how rotation works. Yes,
maintain its position.
That's how rotation works. Yes.
But I thought gravity got weaker the further you're away from it. You can understand our skepticism because it's a bit far-fetched.
No, it actually matches what gravity says should happen. Again, your skepticism is based on an ignorance of what should happen.
No, it's not so much ignorance. It's just, can you demonstrate in any experiment that you're saying something so much further away can also take a corner a lot faster than something a lot closer, so that it all seems like it's not changing in our perspective over thousands of years.
Again, just look at a record. Well, just saying it's a bit far-fetched is personal incredulity, and saying that that's not what we should see is a straw man. Howard, what we see with the stars is what we should see. It matches the physics of the universe as we understand it. It matches what gravity says should happen with the rotation of the galaxy around the center, around Sagittarius A. It matches what should happen. Your skepticism here is ignorance of... Well, it matches what physics says should happen, and all the experiments we've ever done around physics and gravity. It matches what we say should happen. It matches Einstein's predictions of relativity. It matches Newtonian law within the confines of relativity. It all matches what we expect to happen based on our understanding of physics. and the
But your
millions of
understanding of
experiments that have
physics
been
has been
done.
renewed. Your understanding of physics keeps
Renewed
getting
isn't the right
updated.
word. Refined is the right word. As
Yeah,
you
'cause they have
as
to-
you
they
discover
have
more
to-
things, you refine your knowledge. Your knowledge gets better and better and better. As science never says that we know everything. Science never says that it is right. Science just says that, well, that isn't right, so this is our best understanding right now. But a better understanding might come along. But everything we see with the galaxy and the rotation around the center of the galaxy matches the predictions of what we understand about physics.
Matches your explanations, which
No,
keep
no, no,
getting
not explanations.
refined.
Not explanations, predictions. It matches the predictions based on the known laws of physics.
Well, in all fairness, there was many geocentric astronomers and astrologers that
And
were
they were
able
also
to make
fucking idiots,
predictions.
yes.
They were able to make predictions before the sun got placed in the middle of the universe and before the Earth became round.
Well, they were able
So
to make
when
rough predictions, but never the exact to the millimeter and to the microsecond predictions that we can make now.
But you do know about the astrolabe, which the Arabs and even many other cultures...
Yep, an excellent globe thing, because did you know astrolabes have to be different for the area that you're in? They've actually got they've got inserts. You know, as time went on, astrolabes were redesigned to have inserts so that you could change the positions of what the astrolabe is showing as you change your position around the world. And when you actually look into the maths of how the astrolabe works and what it actually shows you, it matches the predictions of a globe again.
Well, when they designed astrolabes, they thought they were either on a flat or at least a stationary level.
That's an assumption.
geocentric.
You have no evidence of that.
Well, people like Ptolemy were geocentric astronomers and astrologers.
He still thought the Earth rotated, and he still thought the Earth was a globe.
Maybe I'm reading a different Ptolemy. But the point was that all the royal families throughout history have had astronomers and astrologers, and the majority of them thought that the Earth was stationary. And
that's an assumption. You don't know that for a fact. You're just saying that. We've known the Earth was a globe for many thousands of years. In fact, the first known actual globe with a map and stuff on it is from before the time of Jesus. It is from about 600 AD, and it's a globe that was that had all known continents of the time on it. We've known the Earth was a globe for thousands of years. Most people have accepted that the Earth is a globe for thousands of years.
I disagree from all the yin-yang symbols and all the different...
Tradition
like
doesn't change the fact that knowledge has changed. Knowledge has got better. And the fact that there is... Howard, the fact that there is a globe from 600 AD shows that for at least 2,300 years, we've known that the Earth is a globe.
Believed. I could agree that people have believed, but they couldn't know.
Well, they couldn't know anything, correct, because they didn't have the tools to know. But what they could do was use their best knowledge to map the world. And when they saw that mapping the world with cartography matched putting it on a sphere, well, that's what they did. And they created a globe. And all of a sudden, maps became more accurate. Once they learned that the Earth was a globe, and they could create flat maps that were distortions of a globe, maps became a lot more accurate.
Well, I've seen lots of old maps that are on a flat model, and I've seen other maps that are on no model. But to not go off point too much, we were talking about the wobble.
Yeah. Just before we carry on, I just want to say hello in the chat to Rebel Music Resistance, who looks at me and says, "What a pillock you are, fat tits." Thanks, dude. I love you very much. But if you are going to insult me and my incredible man boobs, the correct insult is fight the tight shirt. Thank you very much.
So if we're going to talk about the wobble of Earth happening every 6 to 14 years...
I mean, it happens all of the time.
It's
wobbling all of the time.
If we can supposedly measure 0.5 meter to 1.5 meters change in 6 to 14 years, then imagine 60 years, imagine 600, imagine 6,000 years. There should be a lot of parallax just with the North Star Polaris. Never mind all the other stars. And here's my point, Craig. if you're telling me the Earth wobbles that much, then surely all of the other stars, all of the other suns, planets, all the other things in the sky should be wobbling too, as they're all following the same path as us around the Milky Way. Shouldn't they all be wobbling? So if we're wobbling...
Stellar parallax shows that's the case, yeah. That's exactly what we see.
But apart from some almanac reports or whatever, almanacs, reports,
yeah, sailors' almanacs that they used for celestial navigation to accurately get from point A to point B, yes.
Have you got anything that goes back a bit further in time that isn't so easy to, to invent? Because people could have, manipulated or invented these reports to support
Howard,
your theory.
I really don't care if you think that things were manipulated or lied about. These are historical records which match historical records from other places on Earth from people that never met throughout history.
But
shipping companies. There's records from shipping companies that travel the planet, right? And shipping companies that were run by China and shipping companies that were run by Great Britain, the British Empire. These shipping companies, they hated each other, right? But their almanacs that they both use over hundreds and hundreds of years show the same shift in the position of stars. Because it's what they had to use to actually navigate the Earth.
Well, I've compared your almanac reports to artifacts that are in stone and metal.
Howard, come on, you're going around in circles. I've told you, those artifacts do not contradict the almanacs. Those artifacts have no accurate positions to the arcsecond. They don't. They just are rough depictions of what the stars looked at thousands of years ago. And those rough depictions match what we say the stars should have been.
Aquarius is carrying water in all traditions, in all civilizations, throughout all history.
And that's no problem for our model. That is no problem, Howard. All these things you keep saying, they match what we say should happen.
But you're telling me there's a wobble of everything.
Yes, and we chart the change in positions of stars due to the wobble of Earth's axis. We chart the fact that Polaris changes position due to that wobble. We have records of this happening throughout history. Polaris being roughly in the center thousands of years ago does not contradict what we have with records from the past 1,000 years that ships had to use to navigate. Nothing that you are saying about the stone tablets and everything contradict what we say is the case. Nothing.
Well, you're saying that since the 80s, Polaris has moved noticeably.
Yeah.
Well, then
it has in several arcseconds. Yeah.
Well, we've been taking photos, videos, and we've had telescopes for quite a long time now. So I tell you what, come back with some stronger evidence. I'd be very interested to see
stronger evidence than recorded positions of the movement of stars.
You should be able to support what you're saying with a bit more evidence than just telling me some almanac reports. You should be able to show me almanac reports. And maybe
I can show you what you can find them mctoon.net/Polaris. There's loads of them there.
I'd prefer that you display them and maybe present them and explain them to me in a week or two's time. Take your time and see what you can find to support your theory.
I've just told you I have actual historical almanacs, and I've just told you where to find them. They show the changing positions of stars.
And I've got actual artifacts and stone carvings.
Okay, Howard, you're going around in circles. Again, did you not hear me when I said your artifacts do not contradict my almanacs? They work together.
I think they don't. But I tell you what, let's leave
what
that
you think
now.
Is irrelevant. It's a fact they do.
What you think is irrelevant too, Craig.
Well, no, we have actual records that show the changing position of stars. You do not have the exact position of stars thousands of years ago. Do you agree that what you have is the rough position of what stars would have been thousands of years ago?
Do you agree that what you've got is...
Come on, answer my question first, Howard. Be fair. Answer my question first. Do you agree that what you have is the rough position of stars from thousands of years ago?
I wouldn't say rough, because the 88 constellations have been mapped out the same all over the world from hundreds of years ago to thousands of years
And
ago to
do they have the
multiple thousands of years
positions
ago.
of stars 100% accurate to the, the micrometer? Do they have that, or are they just the rough position of stars based on some dude looking at them and chiseling it down? That's what they are, right?
Let's see it. Let's see if you can answer my question for me. Don't you think it's strange that people joined? Look, when you were a kid and they gave you something at a restaurant to join dots, don't you think it'd be weird that you and kids all over the world join the same dots and make the same 88 constellations?
No.
Yet you're
Why
all
would I
in
think
different
that's weird?
restaurants all over the world. There's no communication. No one said, yeah, I think that's someone carrying water.
When
you
would
should
that
copy
happen?
me and... Huh?
Howard, the position of stars are as we expect them to be. Thousands of years ago, they would have been in roughly the same position that they are now, right? But we have, as time's gone on, and we have better measuring equipment, we have been able to more accurately chart the exact position of stars. The movement of the stars is very, 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 very slight, but enough to be recorded. But not enough that thousands of years ago, the stars would have been vastly different. Thousands of years ago, the stars would have been pretty much the same. Okay?
If that was true, how come somebody in South America joined up the same dots and made 88 constellations like someone in
Because
China,
we all see the
like
same
someone
sky.
Huh?
Throughout the year, we're all going to see the same sky.
Yeah, but why would everyone say that's Orion and he's got a belt?
They didn't.
Surely-
They didn't all say that's a lion. The actual what people said the stars and constellations were is different throughout different cultures. You do realize
But
that, right?
But they joined the same dots and made the same 88 constellations.
No, they didn't. Many different cultures throughout the world had different symbols and different shapes for the constellations. They weren't the same. Not until much more recently. And even now, the Chinese have different names and different symbols and different shapes for the stars than we do.
But they joined the same dots and made
No, they
88...
didn't. They're not all the same.
You're gonna have to back that statement up, Craig, because I think you're wrong.
The Chinese literally have different names for the constellations, different constellations than we do.
But you saw the swastika also came from China and Japan, and it was the Big Dipper around the North
Big Dipper is a
Star.
very obvious one, but they didn't call it the Big Dipper. And again, we are all going to see the same stars. But not every culture throughout every point in history joined the same dots. That didn't happen.
Right, well, you're entitled to your beliefs.
I don't have a belief.
Really...
Do not strawman me and tell me I have beliefs. I do not have beliefs. I have historical records.
You agreed that they believed, some people might have believed the Earth was a globe thousands or hundreds of years ago.
People thousands of years ago is irrelevant to me. I do not have beliefs. I base my position on evidence and logic. I do not like it when people tell... No, you don't, Howard. With respect, you base your position on an ignorance of physics and basic science.
With all due
what
respect,
it should actually be.
With all due respect, you haven't been to space, and you haven't even taken any videos or photos at water level or at mountains. You're using other people's
I've done many,
images.
actually. I've done many, actually, but that's irrelevant. Nothing in science requires you to only use first-hand evidence, so I don't really care about that.
No, but that means that you have beliefs that are supported with evidence and logic and reason.
No. I don't have
beliefs.
beliefs. I have a position based on logic and evidence. I don't like it when people say I have a belief. I do not follow that belief, is I have to have a belief. I don't. What I base my position on is evidence and logic. Belief is irrelevant to me. Right? And that's something that you need to understand. Belief is completely irrelevant. I have tested the world. I have tested the claims. So I know that the claims are true. I have personally measured that the Earth... No. I have personally measured that the Earth rotates. I have personally measured there's an attractive force due to gravity. I have personally seen... I've personally tested the the measurements for curve by, you know, my work in the Royal Navy or calculating fuel consumption. I have personally tested the things that other people have gathered evidence for. So I don't need a belief because I've personally tested these things.
But you did say that science is always redefining itself and its explanations and its theories because of new evidence that comes out.
Because of new evidence, yes, absolutely. And if new evidence is presented, my position changes because I base my position on evidence and logic. So if new evidence is presented that is better than the previous evidence, my position will shift in alignment with that evidence, because that is how to do science.
That's how we should do science. But as you know, we do have confirmation bias because of what we believe to be true, because of testing things
belief's
ourselves.
irrelevant to me. Belief is irrelevant to me. It's
really is. It's a word. It's
a word that is irrelevant to me.
Okay, how
I
did
don't
you
have
say
beliefs.
It?
Sorry?
You do, but how did you call it? You have a position.
I base my position on evidence and logic. Belief is irrelevant.
Yeah, but you do agree that your position could be invalid, it could be erroneous, and that with new information you would be you'd be wise
with
to
new
change
information
your
I would
position.
refine my position. Yes, belief is irrelevant.
It's a word, but so for the moment I'd like more evidence about this wobble. I'd like to see stronger historical evidence than just
have you ever looked for the historical evidence?
Because I can see artifacts and carvings.
Sorry, Howard, have you ever looked for the historical evidence of the wobble of Earth's axis?
I would like you to present stronger evidence.
No, that's not what I... Howard, come on. We agreed you would answer questions. Have you ever looked for the evidence?
Yes, and the weakest evidence I've found is why I'm asking you to see if you can present something stronger. Because
the weakest. What evidence did you find?
What we've spoken about, that people can talk about it moving and changing, yet all of the historical.
So you didn't actually look for any records or anything.
And constructions, not just like the Georgia Guidestones that was put up in the 80s, but the pyramids that are aligned with the...
I debunked the pyramids in my last video. So in the time of when the pyramids of Giza were built, Orion's belt did not form the 38-degree angle to relative to north that it does today. It actually was closer to 47 to 50 degrees.
How can you prove that, Craig?
Because of the change in position of the stars throughout time that have been recorded.
But where's your evidence that this recording's true? Because if I may, it's not just the pyramids.
The fact that it was used for navigation for centuries. The charts that show that the stars have changed position have been used for navigation. That is empirical evidence.
Could have been tampered with, just like people say
I don't
the
care if
Bible
you think it could have been tampered with. You have to present evidence that it was tampered with, otherwise I dismiss your claim.
I don't need to provide evidence of a possibility.
Yes, you do. No, it's your claim that it could be tampered with. You need to present evidence that it could have been tampered with.
Craig, let me finish a sentence, please. Just as we all are told that religious books have been tampered with, then we know that it is a possibility that your almanac reports could have been tampered with. So it's a possibility that exists. I don't need to prove it exists. It's obvious that it's...
You need to present evidence that that possibility exists.
It's obvious that that possibility exists.
Okay, so you need to present evidence that something actually happened. Otherwise, we will take the almanacs, the several different almanacs from different positions around the world that all correlate with each other throughout history. We're just going to have to take the words that they were used.
You've said it so many times, but what I'm trying to get through to you is it's not just the swastikas and the zodiacs on ceilings and the Mayans and the Aztecs. It's also that the pyramids of Giza also align with the Mexican pyramids. Is it the sun, the moon, and the other one?
Yeah, they don't actually. That was if you go watch a video called the Orion theory, that's actually debunked in it. The positions aren't even relatively similar.
Well, I've seen that there's 3 pyramids in Mexico, there's 3 pyramids in China, there's 3 pyramids in Egypt that I have been to, and I believe there's 3 other pyramids, maybe in Bosnia or something, that all match Orion's belt. So they're different parts of the world, different times supposedly in history, and they are all suggesting that Orion hasn't got fatter or thinner in thousands of years.
No, but the angle of Orion's belt has changed by about 13 degrees.
I don't see any evidence for that. It's just hearsay in some reports that could have been manipulated.
No, it's not hearsay. It's actual historical records from several different sources that all say the same thing.
But
so there we go. There's the evidence, right? You have to present evidence that evidence is false. Otherwise, we cannot dismiss that evidence. Just saying it could have been tampered with is not evidence that it is false.
Pyramids.
Yeah, present evidence that all of the pyramids you just say exactly match each other. Because I'm telling you now, they do not.
Pyramids, swastika, and zodiac carvings.
Yeah, I just debunked all of those. Howard, why did the zodiac get changed recently? Why did they add an extra zodiac?
Because, look, I don't have the answers, but if
I do, because the stars have changed so much.
Possibly.
Exactly. There we go. The stars have changed so much, they literally had to add an extra zodiac.
Please, I didn't say that. What I'm trying to say is...
No, I'm saying that. That's a fact.
It's an opinion. So things might be changing.
Sorry,
right
one
now.
sec. It is not an opinion that they had to add an extra zodiac. That is a fact.
No, your opinion on why they've had to do it is not a fact. It's an opinion.
Oh, no. They said that they did it because the stars' positions have changed. That's literal reason they did it.
All right, Craig. If that was so simple, why is it that they've just added a constellation? Why is it none of the other constellations have changed, but this whole new constellation has just appeared out of nowhere, but it's unaffected anywhere else?
What constellation appeared out of nowhere? What constellation was that?
Isn't it a snake or something, funny enough? A serpent.
No constellation appeared out of nowhere. The stars' position slowly changing required them to change the zodiac so that they could still peddle this nonsense to people.
In the last, few decades, no?
Yes.
That's weird, though, isn't it? That for thousands of years there was no other constellation, but just the last few decades, something's happened.
It's because it's got to the point where it changed so much that they could no longer keep going, oh, well, that could be that's what it is. They had to change it to keep up the farce of zodiac signs.
But just in that part of the sky right there, yeah? Not
no, all the stars have changed positions. All of the stars have changed positions. Howard, all of the stars have changed positions, so much so that they had to change the zodiac. That means the stars have changed positions. We have records of the stars changing positions. Your denial is irrelevant. We have evidence. That's all I need.
I'm getting hearsay, but the evidence showing...
Historical records is not hearsay.
But you're only telling me about these records. That's
mctoon.net/Polaris. You can find them all there.
All right, so what about all the stone carvings, all the constructions of pyramids?
I've explained all that to you already, Howard. Did you not listen? They are relatively the same.
But you're contradicting yourself. You're saying...
I'm not contradicting myself at all. I'm just saying in the last few decades, they changed it because it got so bad with the shit that the positions have changed over so much time that they had to update the zodiac. It got to that point. That's it.
Only in this one part of the sky right there.
No, oh my God. You don't listen to anything that's told to you, do you? No, not in just this one part of the sky. All of the stars have changed position, so much so that they could have this new constellation and change the zodiac for it. Listen to what you're being told and stop doing the flurf reset.
Listen to what you're being told. If this one part of the sky has changed so much...
It's not the one part of the sky, Howard. I just told you it is not just the one part of the sky. All of the stars have changed position, so much so that they had to adjust the zodiac. Stop strawmanning it.
Stop getting your knickers in a twist and let me finish my sentence.
Stop repeating yourself over and over when I've already answered you.
No, but I'm not convinced by your answer.
I don't care if you're not convinced. That is the answer.
Please let me finish what I'm saying, and then we haven't got to talk over each other like children, yeah?
Yeah,
So
well, please stop
if
repeating
you're saying-
yourself then.
If you're the one that keeps repeating yourself, Craig.
I'm repeating
if
my
you're
answer to you. You are not accepting the answer and repeating
Craig,
yourself, okay? Please
Craig.
don't... Right, I'll let you finish, Howard, but please stop repeating yourself when I've already answered your question.
But you're not listening to what I'm saying.
I am. I am
Yeah?
listening to what you're saying, and I am responding with the reasons why that is the case.
You're responding with your opinion, but you've contradicted
I don't have
yourself.
opinions, and I haven't contradicted myself.
Please stop being so big-headed. And
I'm not
thinking you
being
know
big-headed.
everything.
I'm not being big-headed. I have not contradicted myself. Not once.
Craig, let me get a word in now, otherwise it's boring.
Please stop repeating yourself, though. Please stop telling me I've contradicted myself, because that is not the case.
It is, and I'll explain it if you stop interrupting me for once. Right. So if you're saying that they've all changed, then show me that they've all changed. Because
MC2.net/Polaris.
That Orion hasn't got any fatter or thinner, and Aquarius has still got water, Scorpio's still got claws. If they're all changing, then they wouldn't be recognizable.
The angle to Orion's belt has changed. I've told you that the angle of Orion's belt relative to North has changed. We have historical records of this. They are not going to change so much that the recognizable constellations are completely unrecognizable, because all of those stars are traveling around the galaxy with us. But they have shifted enough that we can record the movements, and they've shifted enough that we had to add an extra zodiac. Nothing in that contradicts what I am saying.
I disagree, because if
I don't care if you disagree, you are wrong.
Please stop doing the 666. It doesn't work on me. It might
that's not
hypnotize your
666. That's just a hand motion that I do.
Yeah, I bet you do a few other hand motions as well, but we're not getting to that. So my point is, Craig, that if you can make a new zodiac, then you can surely have disfigured all of the others, or some of the others.
Yeah, and like I said, Orion's belt has actually changed its angle relative to North. There we go.
So you say. So
so historical records say.
Not my historical records.
I don't care. No. You don't have any historical records. The historical records have the historical records. You just deny them because you have to. Because here's the thing, Howard. You are only a globe skeptic. You are not a flat Earth skeptic. And that is dishonest.
I'm looking at the zodiacs carved in stone by the Aztecs, the Mayans, the Egyptians.
Yeah, and they've changed. We had to add a new one, remember? We just discussed that.
Yeah, well, that could be something else, like
what could it be? What else could it be?
I'm not really here to preach religious beliefs because I'm very open-minded, but it could
No, you're not. You're not open-minded at all. You are denying evidence because you think someone possibly could have at some point tampered all of the different historical records from different people throughout history to all say the same thing. That doesn't mean you're open-minded. That is the opposite of being open-minded.
Let's be fair. You're ignoring evidence.
I'm not ignoring it. I have not ignored any evidence.
You are.
I have not ignored any evidence. None at all.
You're ignoring the evidence, the reasoning, and the logic that I'm.
What evidence have I ignored, Howard? Specifically.
You're ignoring that you've contradicted yourself, saying that they're moving so much.
I didn't contradict myself.
I think you have, and I might be able to.
You're wrong. I have not contradicted myself.
You might not agree, but you've literally said they're not moving that much that you can tell. But you've also said they're moving so much that we've had to. Please stop interrupting me, Craig.
Stop lying about what I said, because I didn't say that.
You've literally said that we've had to add another constellation, and Orion's belt's changed
another zodiac. Yes, it has. Yeah.
But then you're saying that they haven't changed that much that you can notice. So
it's very hard to notice with the naked eye, because the positions have changed very, very little over thousands of years, but enough that we had to add a new zodiac, enough that the position of Polaris has been recorded as changing. In fact, all of the stars that are used for celestial navigation have been recorded throughout history to change position. However, their relative positions to us have stayed pretty much the same.
Okay,
That's
how is
it.
this not a contradiction? Don't you dare interrupt
It's
me.
literally not a contradiction. I just explained how it's not a contradiction.
Don't get your knickers in a twist. Let me finish speaking. So 1 minute you're telling me that, you know, Orion's belt's this way, and now you're telling me Orion's belt's that way. It's only a little bit of a difference, but the angle's changed. Make your mind up, Craig. Come on.
Yes,
Is
the
changed?
angle of Orion's belt relative to north has shifted by over 10 degrees since 5,000 years ago.
Wow, you've got some strong beliefs there, mate.
That's
You
no
can't know
belief.
that.
That's not a belief. That has been recorded throughout history.
Not on the artifacts I was showing.
Sorry, the artifacts do not contradict the recordings.
In your opinion.
No, not
Right,
in my opinion, in the fact. You've done it again. You've done the Flurf reset again, Howard. I've told you the answer. You can't accept it because you have too strong of a bias towards the flat Earth.
I would say the same to you, Craig.
Oh, no. I can explain all the things that you say, but you have to ignore them and deny them. I don't deny anything. I agree with you that the ancients carved the positions of the stars in stone. And I agree with you that they're pretty much the same as they are now. They are not 100% exactly the same, though.
It sounds like
it.
Orion's got a completely different angle, and that there's a new constellation.
Orion's belt has changed its angle relative to north by about 10 degrees, and this has been recorded throughout history. Okay? That's it. Right? No, that's it. You can't deny it. Historical records. You have to go and debunk every single one of the historical records, otherwise you have no evidence of your own. All right? So what, we're going to move on now because I have answered all your questions and all you're doing is just denying everything that I say, even though I have historical records to back me up. So we're going to go on to your third point. All right?
Like, I think the same for you. But great, let's move on.
Well, you're wrong. And that's the fact of it, because I have not denied anything. I have not contradicted myself. I've explained everything, and I have shown you the models, and I've told you where to find the records yourself. That's it. Okay?
But you sound
we're moving on to your third point. All right?
Yeah,
moving on to your third point.
Just saying.
No, you don't need to say. You're moving on to your third point. Okay?
You sound like a bit of a know-it-all, but that's okay.
You can call me a know-it-all if you want, Howard, but that's because I've studied things and actually looked for the evidence.
So you do have your strong beliefs. I get
no, I don't have a belief. You keep saying that, but I don't have confirmation bias because I base my position on evidence. And whatever the evidence shows me, that is my position. That requires no bias.
But you favour evidence that suits your narrative.
No, I don't. No, not at all. Please don't strawman me. I do not favour any evidence. Whatever any evidence is, I will scrutinise it the same, regardless of what it's from. All right. The fact is that the fact is I have analysed all of the evidence I have ever been given, and the conclusion that I draw from that is that the Earth is a rotating globe because I have tested every single claim myself.
There was one little thing.
No, can we just go on to your third point?
You said you draw the conclusion
based on evidence. Yes.
Just like your opinion again, don't you think it's a very strange conclusion that all over the world people joined the same dots in the sky?
They didn't. The different cultures had different names and different symbols for the stars in the sky.
Maybe different names.
Anyway, your third point. Space exploration skepticism. Can you demonstrate how both a solid landmass and a gas giant could reflect sunlight towards us when the sun is positioned behind it? What?
Well, let's play the video, because planets like Venus can twinkle very bright in the blue sky before sunrise and also after sunset, depending what time of year you make the observation.
That makes sense, yes. You can absolutely see Venus and Mercury.
When you search for pictures of Venus in space, you get these NASA Science for Kids images where they're all different colours and totally different animations, because it says it's NASA Science for Kids. It shouldn't really be taken literally.
Did you look for like actual pictures from telescopes and stuff?
Well, all of the pictures on the internet look pretty Photoshop.
No. Did you specifically look for pictures through telescopes? Or did you just did you just randomly look for something? Did you specifically search for actual pictures of Venus through a telescope or something like that? or did you just look for animations or something?
Well, a lot of these images are from NASA, the European Space Agency,
and how many of them say that they're actual pictures? How many of them say they're artists' impressions? How many of them say they're simulations? You know?
Why are there so many artist impersonations? And
because Venus is really far away, and sometimes they do artist impressions. That's the thing. NASA has a public relations department, right? NASA has to, put pretty pictures out for the public, and if they're planning a mission to somewhere, like putting a probe on Venus or something, they're going to do an artist impression of what that looks like, because it's something nice to look at whilst we're planning the missions. Artist impressions are things. Space is an amazing thing to make artist impressions of. It's a thing that happens. The fact that there's artist impressions is not evidence of anything. Moving on. Yeah,
but they could probe Uranus, Craig. But once they've been there, they're going to show...
My Uranus has never been probed. I can guarantee you that.
So here we can see Venus in the blue sky. And this is actually Mr. Sensible's video. You can play it, actually. He says it himself.
That's the moon, and directly above it is Venus.
There you go. And here's my video showing the same. The sun's just set, and you can see the moon while the sun is supposedly behind the moon.
Yeah.
Yeah, so just let it play.
Sometimes setting behind Venus. It still appears as a bright star to us.
Yeah,
there you go. He was honest. So I'll just explain this. So as we can see with my crappy camera, my phone camera, the same as with the naked eye, Venus is flickering really bright after the sunset.
Yeah, because it's a crappy phone camera,
Let me just explain. Here, the video on the right is showing Venus, Jupiter, and Mars, all in the early morning before the sunrise. So again, the sun is behind it, and it's glowing very bright, which suggests it's emitting its own light and not reflecting the sun.
Wait. What do you base that on? Why can a reflection not be quite bright?
As Simon Dan admitted himself, the sun is sometimes behind Venus, and it's still glowing and flickering very bright, which means we're looking at the dark side of this gas giant.
No, that's not what he said at all. That's not what he said, that it can appear in the sky as though that is, but because that's, you need to look at it in 3D. So what is your objection here? Is it the fact that you can see these things in the sky at the same time?
If you rewind a little bit, just a little bit, you can see this last video that's on the right side of the screen. Keep going just a little bit further back. That was a beautiful... that's Jupiter, and just next to it you can see Mars, I think.
Yeah.
But if you go back a little bit, you'll see the moon. You'll see the moon a bit further back. There you go. So we got the moon, and we've got Venus. Now you can see that the moon is only partly illuminated, so the sun is clearly behind the moon, which means the sun is clearly behind Venus as well, which is next to the moon. And the video, and if you let the video keep playing, you'll see.
Why is that an issue? You're just you're just saying things, but you're not saying why it's an issue.
I will just let the video play, and then we can get a bit more into it. I will just let the video play, and we can all see the moon again as I zoom in.
The flickering is a funny one. I would suggest that this is down to the poor focus in the clip that Howard is using here from his camera.
Absolutely.
Yeah, but you could see the moon, the sun was behind it. So when we see flickering in brightness, shapes, colour, size, where is the distortion? Because I don't see any missing bits. And when we look at the planets and the stars...
That's what happens when it's trying to resolve something.
I may just do the presentation so I don't forget anything, and then you can talk about it with me. So we can clearly see the planets are in focus because we can see the phase of Venus's illumination, just like we can see the patterns are changing colour, size.
They're literally not in focus. All you have to do is actually look at in-focus videos and photos to see they're not in focus. Those are not in focus, Howard.
Well,
Howard, they are not in focus.
I would disagree with you.
You can use better cameras and telescopes and get pictures that show this is not what they look like. Those are not in focus and is not what they look like. Alright? I'm not going to take any bullshit from you here. That is the answer. They are out of focus, poor images. If you actually use decent quality equipment, you can get much better images. Don't argue with me, that's a fact.
I will argue with you.
No, I'm not letting you argue with me about that. They are out of focus nonsense that you can see. You can get much better images with better cameras, with better telescopes. You can actually get images that look nothing like that. Every single one of those images, every single one is out of focus nonsense, and I'm not going to let you bullshit anything else. They are out of focus, poor quality images. End of story. No discussion allowed.
You find it a touchy subject, but we'll
No,
get into
it's a
it
fact because it's the fucking most moronic bullshit ever. This is clearly out of focus fucking nonsense. That's all it is.
Right.
And if you can't see that, then you're actually brain damaged.
Craig, you can insult me as a person.
I didn't insult you. I said if you think this is anything other than actual out of focus nonsense, then you are brain damaged. That is not an insult. That is a fact.
I will argue with that point in a minute.
Well, then you must be brain damaged, because if you cannot see that they are simply out of focus nonsense, there is something wrong with you. You can, right, the fact, here's the thing, Howard, there is millions of pictures that are better than that, all right? Are they all fake, or are these ones fake? Which one is it?
Let's stick to my points, and
No,
then
you answer my question. You answer my question. Are all the millions of pictures of every single one of those things that are in focus, are they all fake?
Well, at the start of my video, I showed you Google image search, and I can't seem to find anything.
No, that's not what I asked. All the
pictures.
millions of pictures of those things, actual pictures that are taken by astronomers and professionals, amateurs and professionals, all the pictures that we have which show them in focus, are they all fake?
I'm asking for a video.
Okay, answer the question, Howard.
Answer mine.
No, I had the question first. I had the question first. All right. All of the pictures and all of the videos that we have which show them not to be like that, are they all fake?
Show me a video.
Why can't you answer the question? It's a yes or a no, right?
I want to see one. I want to see a video.
I'm going to ask the question once more, and I want a yes or a no answer, Howard. All right? I'm talking. Are all of the pictures and videos that show them not to look like that are in focus, are they all fake? Yes or no?
Show me one.
Yes or no?
Show me one.
Yes or no, Howard?
I don't know. Show me one.
Right. Have you looked for them?
Yes, and I only find artist impressions, which is why I
have you looked for a video of someone recording Sirius? Yes or no?
Yes.
When?
For the last 5 years.
Right. You've looked for a video of the star Sirius, yes?
Yeah, and
when? Prove it. Like, show me your research. Have you looked for a video of Saturn? Have you looked for a video of Venus? You've never done it. Don't lie to me. Right, I bet right now I can find a video of Venus.
Please do. Because that's what we're talking about, Venus, yeah? Let's stick on Venus, because you're always making an arm-changing point. I want to know how we can see Venus so bright in the blue sky before sunrise or after sunset, when the sun is clearly behind it. It's in between us and where the sun is, yet we're looking at it flickering bright in the blue sky. How is that reflecting sunlight if the sun is behind it?
Right, well, what's the date on the video?
You can wake up really early tomorrow
Howard,
before the sun...
I asked the question, what is the date on the video?
The last video that was next to Simon...
What is the date that those observations were taken?
The last video was about 2 weeks ago, 1.5, 2 weeks ago. You can
was that when I want the exact date those observations of the sky were taken, please?
Tomorrow morning, wake up early and look at Venus before the sun...
Listen to what I'm saying. I would like the exact date those observations were taken, please.
You can make the observation tomorrow morning.
No, I don't want to make the observation. I want to know what date the observation you are talking about was taken. Can I have that information, please?
2 weeks ago I made it, but you can make
it tomorrow morning.
What day specifically?
What day specifically?
You
what time?
will have to look on your calendar at what 2 weeks ago was, mate. I'm just
You were the
telling
one
all
that
of
took
your
the observation. I would like the exact date and time, please.
2 weeks ago. So
Yeah,
if you're
exact date and time, please.
6 a.m. 2 weeks ago.
2 weeks ago, Saturday.
Yeah, and if you make the observation tomorrow, it'll still be the
Right.
same. It's
Right. So,
Go on.
should we look at the model for 2 weeks ago, Saturday, from your position, and see what it says?
Let's look at Venus tomorrow morning. All your subscribers should look at Venus before the sunrise tomorrow morning and see for themselves it's glowing, flickering bright in the blue sky before the sunrise is behind it, which means it's emitting its own light. Because you can't
It means
reflect
it's emitting its
sunlight
own light.
if the
Why,
sun's
sorry?
behind it.
Why
Okay?
did you say it's emitting its own light?
Because it can't be reflecting sunlight if the sunlight's behind it.
If the
Can
sunlight, right? Okay, we're gonna have a look at the model in a sec and prove you wrong with that. But just
Go on.
getting the videos of Venuses and stuff, the video of Venus for you right now. I'm trying to find the one that I used before.
You can use your little cartoon in the background as well. If we're on this side of the sun, and so's Venus, yeah? Then how can Venus be reflecting sunlight if the sunlight's behind it?
All right. Let's just do that. I'll get. I don't have the video to hand right now. I'm trying to find the one I did, but let's have a look at the model like we did before and answer that question. All right, because I know for a fact you've never tried to look if this is possible or not. You've just said that you think it's impossible without ever looking. So let's go and have a look. Let's bring Solar System Scope back up. All right. So the date was 2 weeks ago today. So we're looking. Oh wait, we're June.
You can do it this
2022.
morning. You can do it tomorrow
No,
morning.
we're going to go to that observation that you had, right? 2 weeks ago today is the 14th, right? And what time was it? You said 6 a.m.?
Yeah, there was 3 observations. 2 were mine and 1 was Mr. Sensible's. So
And what was the date and time of Mr. Sensible's?
I don't know, but when I was in Myanmar...
You don't know? Oh, weird.
Guess what? 3 years ago when I was in Myanmar and we were watching a sunrise, before the sun rose, I could see Venus in the blue sky in the east before the sun rose. So it
And
didn't matter where I am,
did you have a
no matter
look if
where
that was an
Mr.
issue, or
Sensible- Huh?
did you have a look if that was an issue? Or did you just make an assumption? Right, so you're in Spain somewhere, right?
Let me explain this really clear. When Venus is just above the horizon and the sun is just about to come up, yeah, sunrise.
Okay, here
So
we go.
when the sun is behind Venus, but Venus is completely bright, flickering in our blue sky, while the sun is behind it. That
Sun isn't
suggests
behind it, you can't think
that
in 3D.
Venus is emitting its own light,
Yeah,
like the moon.
Venus,
is killing
again, you can't think in 3D. Right, so is this the observation that you had? Would you agree? Because this is Spain, 6 a.m. 2 weeks ago today.
Venus. Mars is above, and I think Jupiter's near Mars, yeah?
Let's have a look where Jupiter is.
Jupiter should be near Mars.
Jupiter's over there, right? So we got Jupiter, we got Neptune, Jupiter, Mars, Uranus, Venus, and Mercury, all right? And you think that's a problem, right?
I think that we shouldn't
Let's have a
see the
look.
whole
Let's have a
face
look, shall
of
we?
Venus lit
Right,
up
so
when the sun is behind it.
Where's Venus? So Venus is there compared
Venus
to
is
Earth. Let's go in and have a
Between us
look.
and the sun.
Right. So this is Venus and this is Earth. So at this point, you
So
should be
go
able
back to the other side of the globe. Go back to the other side of the globe.
So this is the night time over here. So this is about the Terminator line, yeah? Right?
Yeah, great.
Okay. So
So do you see it?
So
let me
there we
speak.
go.
back
So
to that
wait, let me finish my point, please. Right. So at this point, at night time here, just in the morning, you're going to be able to see Mercury, Venus, Mars, and Jupiter, just as the model says. That's no issue. There we go. That's no problem at all. Right,
so from
and we
this
can go.
side
We can go
here-
back
hold
into
on,
the
hold
night
on.
sky, back into the night
This
sky, and look at the same thing. Yep, that matches what we see.
Really, go back
Yeah.
to where you were, next to the globe, on the right side of the globe.
Let's make it actual better sizes. We're gonna go not quite realistic, but better, right? So, nighttime is going to be anything where the sun isn't hitting it, right? So nighttime's
Right.
looking this way. Anything over here is going to be just as the sun is rising, right? 6 a.m. There we go. There's no problem with that at all. Matches what we see.
Funny enough,
We've got Mercury,
before you-
Venus, Mars, Jupiter, and Neptune, all in line of what you would be able to see in the night sky just in the morning, matching what it shows in the night sky.
You see,
There's no
what
problem
you've
there with
done
our model.
Craig, is you changed the angle and zoomed
I haven't changed
out.
anything.
Well, if you could zoom back in to how it was when you were talking. and
Yeah,
go
I
back
changed
to
the size of Earth to make it slightly more. Oops, sorry. Right. Alright, so let's go into Earth and zoom out from there, right?
If you could go back to the right side of the globe where you were when I was asking to speak, it showed my point exactly.
Right.
And we
So
could see Venus clear as well.
I'll make them slightly bigger again to make it easier. Right. Solar system. Oh, sorry, I keep clicking off of it by accident. There we go. So, Earth, just in the morning, all right? Anything along this line from here, all right?
Can you
anything...
zoom back in, Craig, and I can make my points? Right, you go back to Earth, on the right side of Earth. Right, now
Like that?
When Venus was a bit bigger before, I could make my points a bit easier.
I'll make it a little bit bigger.
Yeah, it's for your subscribers to see what I'm on about.
Yeah.
Okay,
And,
so
I mean,
even on
that's
this
no
little
issue.
even on this little cartoon, it's showing Venus would
This isn't a
be
cartoon.
illuminated. Craig, please let me finish speaking.
Okay, I'm just saying it's not a cartoon.
On this animation, yeah?
Model.
Go on, Craig, correct me, and then we can get on with it. What do
Yeah,
you want
yeah,
to call
it's on this model,
Doing an
yes.
animation, a graphic? What do you want to call it, Craig?
A model.
It really matters to you.
A model of the solar system.
Okay, on this graphic model of a solar system, please stop moving. Can you see how Venus is half shaded from this point of view?
Yeah.
That's what you'd expect, isn't it? But
And that's
when
what we
we
saw.
see the whole, please let me finish speaking. When we see the whole face of Venus illuminated,
Which is
but we're
like
not-
that. That's what we would see.
that's daytime. That's daytime.
Well, no, this
That's
is
daytime.
looking from the relative position of Earth. I'm just trying to...
No. The other side of the globe was still just nighttime becoming daytime. Now you've gone on the sunset side.
Like,
See, if you could stay still when I told
I'm
you
just,
before,
I'm just trying to get an angle where it shows, right?
where it doesn't
So-
look as bad as I'm proving
No,
it
no, no.
does. So,
You're not proving. In fact, you're disproving your own point. So from this position, which is just going to be, as daylight is forming at 6 a.m.
yeah,
Venus
we
is
shouldn't see the
pretty
whole
much
face.
all. Venus is pretty much from. There we go. So this is looking from the night side of Earth, right? Venus
No,
is pretty
because
much
we
lit
can
up.
see the- No,
So
wait,
is
come on.
Mercury.
We can see the sun. So if we can see the sun,
Yeah.
then it's obviously.
So this side is lit
nighttime,
up. That
isn't it?
makes sense. That matches what we saw. That
No,
Howard,
you're in front of Earth. You're in front of Earth. If
I'm
you go back
looking
on
from the
other
night side of Earth at that point.
Look,
right?
you've clearly changed side of the globe. We all know
I
what
haven't
you're
changed
doing.
anything. Look, I'm showing
if
you
you
from
stay
this
where-
point, which is
stay
when it
where
would
you
just be
are.
coming day, right? You can
Stay
see
where you are.
Mercury and Venus and all of
Stay
the
where you
planets. It
are.
matches
Stay
what
where
we
you
should
are.
see.
Stay where you are and stop talking
Wait,
for a
you're
second.
over talking me, all right?
Yeah,
From
because
this, let me finish, please. From this point, when it's just becoming day, 6 a.m., you can see all the planets exactly as you should. and it matches what we
Right.
saw. It matches your observation, Howard.
You are wrong, because we can
I'm
clearly
literally
see...
not. I'm showing you it.
Why don't you let someone speak, and you might learn something, Craig, instead
Because
of
you're
shouting
just
over
lying
all
at
the
this
time.
point.
No, you just keep changing position and zooming out and talking over me because my point's relative. We now see shaded side of Venus, which is what we would expect to see in the blue sky. Half of Venus illuminated, but we see the
Yeah,
whole...
we're not actually looking from the
side.
night side of Earth at this point. We're looking at a different angle. That's why I did this, because this would be looking from the
Shows
night
less-
side of Earth.
shows less-
This,
no, if that was the night side,
this
we
is.
wouldn't see
I'm talking. This is on the night side of Earth, just at day, what you would see. You see, Venus is mostly there, right? And you can even turn
Still
it around to
shaded.
see where the others are, right?
Even
So
though you've gone to the other side of the globe...
I haven't
and
gone
at
to the other side. I literally haven't done that. Look,
You're on the left
I'm
side.
going. I'm going in
There you
there.
go. Stay
right?
there, stay there. We see more shade on Venus than
Yeah,
than
because we're
light.
not
Yeah.
we're not looking at from the position of the night sky, which is just here. You need to be looking at it that way, right? This is a camera looking at it from outside, so of course Venus's amount that it's lit up is going to be different. You need to actually look at it from the position of Earth, which is why I zoom in
Yeah,
a little
which
bit,
is
right,
why I
and then
said-
turn, because this is looking from the night side of Earth, and most of Venus is lit up. Howard, this matches the observations. This matches
No,
what we should see.
I've made the observation many times, and I'm
Yeah,
telling
and
your
here it
subscribers...
is. Here's the observation. It matches.
Craig,
That's what we expect
here's
to
a-
see.
Craig, here's a model. I'm telling people to make the actual observation at 6 a.m. in the morning tomorrow
Yeah,
morning.
and they will see an observation that matches the model.
No, they won't. They'll see that the sun is directly behind it and it's glowing, which it should be the dark side.
They
of
can
Venus, but we
literally
can-
see that it matches the model, Howard, like I'm showing
Right.
here. Right?
Number one, your model doesn't match because you keep moving
It literally
Number
does.
two- Craig,
Right.
let me speak. Number two, we see Venus flickering very bright in the blue sky.
It flickers because of shit cameras, yes.
No, it flickers on the naked eye as well, so my eye isn't a shit camera.
No, I've never seen Venus flickering with the naked eye.
You've never got up and looked at it. That's why I'm
I've
telling
looked
you
at
to have a
the.
look at
I've
it.
actually done it from the fucking middle of the ocean, so fuck you.
Stop having a fit, Craig. You're gonna have a heart attack. Listen to
You're
me.
just lying to people at this point. I have literally just shown you the model of how it is
Craig,
possible,
Craig,
and you are just
Craig.
denying. Shut up! Don't interrupt me when I'm talking. I have literally.
You're talking
I
shit.
don't inter. Shut up! I have literally just shown you how the observation that you make, which is this observation, is possible with the model of the solar system. It matches the observation that you made 100%.
Yeah, but it also matches tomorrow, and it'll
Yes, it
also
will.
match a month
So,
ago.
do you want to look at it
And if you
tomorrow?
keep-
Let's have a look at what the
if you
observation
keep-
will be tomorrow.
If
All
you
right.
keep changing the dates, eventually
So
you'll see that the sun
let's
is
go
positioned
to
on the-
tomorrow at 6 a.m. Shall we?
Right, while you're looking for that, let me speak. I'm telling people to make a primary observation for themselves, and you're trying to
Here we
convince
go.
everyone not. Please let me speak, Craig. You're trying to discredit and discourage people from making a primary observation
No, I'm
for
not.
themselves.
Don't lie. I never said that at all.
They
I
should
never-
believe you.
I never said
Let
that
me
once.
speak, let
Howard,
me
stop,
finish.
stop.
No, no,
I
I'm not letting you finish speaking
stop.
before you make a
Stop.
claim.
No, stop, Howard, stop.
No, this is where we fall
Howard,
out,
stop.
Craig. Let me finish
No,
what I'm
Howard,
saying.
stop. 1 second. I did not say that at all. I did not once say to people not to make the primary observation. Do not say that, because I did not say that.
You are implying that people shouldn't bother making a primary
No, I'm not.
observation.
No, I'm not.
You-
I have never said that. I have never implied that at all. Do not lie.
Right, so when I'm trying to tell people to make the observation and you're saying, but I've already done it, you're calling me a liar? It's like
I'm not.
what? We're all supposed to
I'm
believe
not
you.
saying that anyone shouldn't make their observation at all. I have never said
Right
that
then.
at all. In fact, I encourage
So-
people to go and make the observation and then compare it to what we should see,
Right, so
which is
ignore
this.
your model for a second. If everybody that's listening can wake up tomorrow at about 6 a.m., I'm not sure if in the UK it's different, but here in Spain you can wake up at 6, 6:30, and you will clearly see Venus close to the horizon before the sun rise, and you'll see that the sun rises behind it and then it disappears. But until the sunrise, you can see it bright in the blue sky while the sun is below but behind it.
Yep.
So that means that it's emitting its own light because it can't reflect sunlight from behind it.
It's not behind it. I've just shown you how it's not behind it with the model, Howard. This is the observation you will make tomorrow morning, right? 6 a.m., this is what's going to happen, right? So let's go back to 6 a.m. So at 6 a.m. here, you're going to be able to see Uranus, Venus, and Mercury in line with Mars and Jupiter. And then the sun is going to come up over here, right? The reason you can see Mercury here is because the sun is reflecting the light off of Mercury, which is coming to your eyes.
So you're saying that Mercury is further back than the sun is?
Right, just let's go out to the solar system so you can see it again. Right? So this is tomorrow morning what you're going to be able to see. Right? Venus here, sun here. Light goes from there, bounces off of Venus, comes to Earth. Watch again. Right? I'll zoom in so you can see it. Light comes from sun, bounces off of Venus, comes to Earth. I'll do it once more, a little bit closer so that you can see. Light comes from the sun, bounces off of Venus, comes to Earth. There we go.
Yeah, but if you took the observation about a month ago, it'd be further in front of the sun.
Shall we do it a month ago? Let's do that, shall we? Let's go a month. Let's go back to May, and we'll do a Saturday because it's Saturday now.
And right, like I say, while you're showing people your model and explaining...
So Venus, where's Venus?
Even your model shows half of Venus is shaded, yet we don't see half
Not from
of
the
Venus
position of Earth, from the position of the camera.
We see the whole face
here
of
we go.
bright, flickering in the blue sky. Even with the naked eye, you can tell that it's not reflecting sunlight because it's too bright to be seen in the blue sky, especially when the sun is behind it.
I mean, you can see that, except I literally just showed you how it's reflecting sunlight.
On the slide of it, but definitely not in between it.
No, I just showed you exactly what we expect to see, which matches the observations.
Well, you wouldn't expect to see Venus flickering so bright in the blue sky.
Yeah, well, have you got any evidence to back up that claim that you wouldn't expect it, or are you just saying things? Right. So here we go. Venus there. So the sun's down here. Let's go out to the solar system and have a look how that compares to reality. So here we go. This was the observation 1 month ago. And look, once again, sun. Let's follow the path of the light, shall we? All right. Sun goes to Venus, goes to Earth. We'll do it once more. Sun, light, bounce off Venus, go to Earth. No problem. No problem at all.
Yeah, you can see matches half of Venus is shaded. So isn't half of Venus shaded when you're on the other side of the globe again? No, the other side of the globe, Craig.
Yeah, the camera... You're looking from the camera right now, not from the position of Earth. This is looking from the same position as Earth is looking. And look, Venus is mostly all lit.
Yeah, but on the other side of the globe it's not, is it?
Not from the position of the camera, no. Because the camera isn't on the night side of Earth. The camera is looking at a different direction. Again, this is what looking from a relative position of Earth. This is what we would expect to see. See how Venus is mostly up. So
half shaded, yeah.
Literally not half shaded, mostly lit up, right? And that matches the observations, Howard. I have just shown you how it matches. I am talking, you keep over talking me. I have just shown you how it matches the observations and you are still denying it. It is not my problem you cannot think in 3D. This is not the position that you would see Venus from. This is a camera looking outside of it. To get that position, you have to... I'm talking! Stop! When I'm talking, please don't interrupt my point, alright?
Well, what about when I'm talking?
Oh my god, once again, right. To look at Venus... To look at Venus from the same position as Earth, you need to have... You need to be looking in the same direction. This is looking in the same direction as nighttime on Earth. And look, most of Venus is lit up. There is a small portion that would be the dark side. That matches the observations that we saw in reality. Matching the night sky. It matches the night sky that we see.
You haven't made the observation. You're just looking at a model, a graphic of a model, Craig.
And it matches the observations that you showed me.
No, I'm telling you and all your subscribers to actually make the observation and see.
Yeah, we just looked at your observation and it matches that.
No, it doesn't, Craig.
It literally does. The Nile is also a river in Egypt.
When you're on the
The
other
Nile
side
is
of the
also
globe,
a river in Egypt, mate. You know that, right?
Yeah, I know, but that
Yeah. So your denial is irrelevant here. I have just shown you how it is possible. You ignoring it is irrelevant.
I'm showing you how to make a primary observation, but you're ignoring it.
And everyone can go and do the primary observation and then compare it to the model, which is something you have never ever done. You have never made an observation and then compared it to the model to see if it matches. You've never done that.
I've just compared it to your model,
and
your model shows
it matched 100%. It matched your observation 100%. It matched your observation. It matched your observation. It matched your observation 100%, Howard.
Calm down, Craig. You're gonna have a heart attack, mate.
It matched your observation 100%, Howard.
Why don't you let me finish a sentence?
Yeah. I'm not going to let you lie. It matches your observation 100%, Howard.
It looks really weak.
Yeah, Howard. It matches your observation 100%. I'm not going to let you lie.
Repetition is the best form of mind control, but it don't work on me, mate.
It matches your observation 100%. You cannot deny that.
I don't agree because I'd
agree with you, but then we'd both be wrong.
You'd agree. You might agree with me if you actually listened, but you never let me finish the sentence.
No. You start your sentence with a lie. I'm going to stop you.
Weak.
Okay, Howard.
No,
I have just shown you.
Your model shows me half of Venus is shaded. Yeah,
not from the position of Earth at night, it does not. Only from the position of camera outside of Earth.
On both sides of Earth.
Only from the position of the camera outside of Earth.
Just stop talking and let your guest have a say.
Right,
otherwise, it's boring.
You don't understand. It only showed that much of Venus lit from the position of the camera, not from the position of nighttime on Earth. Okay?
I have made the observation at different times of year from different parts of the world. Even Mr. Sensible's observation shows the same thing. The sun
matches the model. It matches the model, Howard. It matches the model. It does. You can say it doesn't, but you're wrong.
Your model showed half shade, and even then it showed...
No. Again. It only showed half shade from the position... I want you to repeat this, okay? It showed half shade... No, this is important. This is important. No. You need to repeat these words. It showed half shade from the position of the camera.
Your mind games don't work on me, bro.
It showed... From what position did it show Venus... From what position did it show Venus with half shade? From the position of the camera.
You don't let me finish speaking. I don't have to answer any of your questions if you're not going to let me finish speaking. I had a few points to make.
So we both agree. As long as we both agree that it showed Venus half shaded from the position of the camera. Yes.
Even when the camera was on the left side of the globe.
No, it didn't.
I kept telling you to go on the right side, but you went on the left side, and it still showed shade. So
it showed most of Venus lit up. That's what it showed.
But we don't see most. We see all of the face of Venus.
We literally do not.
Right, as my video showed, as everyone can check for themselves tomorrow morning. Don't listen to me. Don't listen to Craig. Check for yourself. That's all science is supposed to be. Verifying.
No, Golden Knight, he does not understand the position of Venus system from our perspective at all.
It's not just about the position of Venus and where the sun's behind it. It's
literally
also how it flickers.
Right.
Please shut up for a second, Craig. It's also about how it flickers. Please, Craig.
Yeah, I'm just saying I'm going to download the next video. That's all. I'm just downloading the next video.
Good. Well, then just let me speak while you're doing that silently.
You can lie, yes. Please
so please, Craig, while people are making the observation of Venus in the blue sky early in the morning, please notice how bright it is and how it flickers like the stars do. Twinkle, twinkle.
And how it matches. Also, see how it matches our model 100%.
Yeah, because your model, you can keep redefining and drawing and recalculating to suit your narrative.
Well, no, it just matches the observations that we make.
No, the observations we make are observations we
match the model,
actually make.
Yeah, and they match the model, yes. The observations that you make match the model we have, yes. As I've just shown.
The model you have was built around the narrative.
Around observations. No, it's built around observations, actually.
Look, just make the observation, everyone, early in the morning.
They will, and they will see how it matches the model.
No model should show a ball of gas flickering so bright when the moon doesn't flicker that bright in the blue sky, does it? Yet the Venus is supposed to be further away, reflecting light off a non-solid surface.
Yeah, if you use a proper in-focus camera, then it doesn't flicker, so, you know.
Use your eye. Use your naked eye. And
your eye is not a in-focus camera. Your eye is not very good at all. In fact, let's use my naked eye, shall I? Oh, wait, I can't see the fucking screen.
Well, guess what? I'm pretty sure even with your shit eyes, you'd see Venus flickering.
No, I really wouldn't, because I literally can't see the screen in front of me.
Well, poor you. Leave them on then. But everyone else, even with glasses, will see Venus flickering bright in the blue sky.
And your eyes are not a good camera that can focus like that.
And then when you get a good camera, it'll confirm what your naked eye sees.
Except it won't. When you get a decent camera and a telescope, you can see that they don't flicker, and they're actually round planets with moons and shit.
Right, so let's put the next video on. Thanks for proving my next point for me.
So, can you demonstrate how the video footage in modern cameras is distorted out of focus while we can clearly see the halo of Saturn? Yes, if they're flickering and shit, then they're out of focus. Next.
So, play the video.
We don't need to. I've just answered the question.
Craig, are you going to censor the evidence again?
I'm not going to censor anything, but Howard,
play the video.
Cameras,
play the video.
little cameras. I'm playing the video. Shut the fuck up. It's my show.
Let
all right?
me talk.
Let me finish my point first, right?
Then pause the video.
I'll do what I want, thanks. So, cameras like the P900 and stuff. Cameras like the P900 and stuff.
Over you. Just
cameras
pause
like
the video and then I'll let you speak.
Yeah, it's paused, you fucking numpty.
Don't swear at me, Craig.
Fuck you. I'll swear if I want.
Don't shout and swear at me, mate.
Fuck you, I swear if I want. Right.
I'll hang up, mate. I haven't got time for
no,
this.
you agreed that you would stay, so you're not hanging up. Right, anyway, so modern cameras like the P900 and the P1000 do not have the ability to properly focus on stuff like that, unless done with really, really decent lenses and stuff, right? They simply are not the right equipment. Get the correct equipment, like a decent telescope, and actually look then. They do not flicker like that. That is out of focus nonsense. Now we will play your video. Fucking okay?
All right. Let me speak.
I'm gonna fucking swear every fucking word now.
So, the whole surface is.
Yeah, look at that out of focus. It's lovely.
Please shut up for a minute, Craig. We can look at the images on the right side of the screen, which are clearly composite images and graphics. You can believe what's in the middle of the ball. You can believe the composition of the elements and all that. Or you can look with your own eyes, and you can look with good cameras and see the halo. And clearly see the halo and clearly see the whole surface is equally as bright. Just like you said about we can see the moons of Jupiter with these modern cameras, we can clearly see the moons also flickering, and we can also see the whole surface of Jupiter is equally as bright. There is no gradient.
Yeah, so that there is simply from...
Let me finish speaking. All of the moons are twinkling bright, so we can clearly see the 4 or 5 moons around it. How is that distorted? How is that not in focus when we can clearly see the moons, which might not be moons, but we'll call them moons because that's what everyone understands.
That is overexposed right there.
We can clearly see the moons of Jupiter. They're all as bright as each other. They're all as bright as Jupiter. There's no gradient of Jupiter. How is that distortion? How is that out of focus when we can clearly see...
Like I just said, that's overexposed right there.
When we can clearly see the halo of Saturn.
So like I just said, that is overexposed right there.
We can see enough detail to see that they're not. But please just play the video.
Like I said, it's that was very overexposed.
Talking, let me look. We've heard your side. Let me just talk. Yeah,
I'm just responding to you.
We can see how water moves when frequencies are played through them. Yeah, we can see how electromagnetic fields are like
nice
torus
cartoons.
fields and donuts. We can see the shapes made in star forts known as bastion fortresses. We see that snowflakes also have similar geometry as the crop circles and the star forts and the symbols and geometric patterns that the stars seem to make, which you call distortion. So even if you don't agree with us, there's a lot of reason why we see symmetry behind these stars.
Because you want to see what you see, yeah.
Please let me finish speaking instead of being so immature, it's boring. We can see a lot of detail. We can see a lot of detail in what we call planets with the same camera that we're looking at the stars. And the stars change color, they change shape, and they change size and brightness in each flicker, which tells us we're not looking at distortion or out of focus, because we see enough detail. We see enough detail in the moons and the halo of Saturn and the phase of Venus to justify that they're not big balls of fire or gas giants or anything else we've been told, but they're self-illuminating luminaries or whatever you want to call them. Like the ancients said, they are self-illuminating.
Yeah, so I'm showing you a video of Saturn right now, and wow, does not look anything like what you said, huh?
Is that a video?
Yes, that's a video.
It looks like a still image.
No, it's a video.
From
JW Astronomy, and it doesn't appear to be flickering or anything. You can see it quite clearly.
It doesn't appear to be a video, though, does it? It appears to be a picture.
It's a video. It's very slow motion.
So it could just be a video of a picture.
No, it's a video. He's recorded it through his telescope.
Really?
Let me. I can get many more. You won't accept anything from NASA, so I won't do that. Jupiter and Saturn through my 10-inch telescope.
It looks like a bit of a graphic drawing, doesn't it? It's
literally it's through a telescope. It's through an amateur telescope. So
well, how come the back part of the halo's got a shadow?
Because the sun would be making a shadow. That's how shadows work. It's quite impressive.
Yeah. Well, how come we didn't see that on the video of Saturn that I showed?
So,
that didn't have any shaded gradient parts. It was completely
because you were showing an out of focus, overexposed video. That's why.
Nah, I still think there'd be some gradient of shading where you're showing it if that was a true video.
Well, that's called a straw man. That's called a straw man. You're making up something that isn't true and saying it's not there, so I don't believe it. I'm going to show you another one that's slightly lower quality, but still way better than what you showed. So just give me one sec.
Really? But the point is, while you're looking for that, I'll talk, yeah?
No, I've already got it. I'm just downloading it.
Even if it's out of focus or distorted...
And overexposed, don't forget that.
Please let me make a point while you're...
Yeah. Just saying, don't forget the overexposed part, though, right?
Please stop interrupting me while I'm trying to make a point, because it's a weak shit tactic that everyone...
I'm just making sure you cover all the points, that's all.
So why don't you just shut up and let me finish my point, and then you can add something afterwards, Craig. So as we saw shaded halo on your image, even if there was overexposure, out of focus and all that, you would still see a darker part of the halo if that was a real video. Then my video would also show a darker portion of the halo, even if it was overexposed and out of focus, it would still show.
I mean, you're saying a bunch of stuff that we should see this and we should see that, but with nothing to back up what you think you should see.
But we don't.
Right, so, we don't, because that's not what we should see. You're making shit up. Classic straw man.
You're making shit up.
I'm not. I'm about to show you another video. All right. Here is a video of Jupiter and some of its moons, and I think Saturn is also in this video. Slightly lower quality, but you can quite clearly see it's not flickering. It's not changing color. It's quite clearly a sphere. And then the moons.
How's your quality better than mine if we can't see the moons?
The moons are there. He actually pointed out where they were. Let me play it again. Again, it is lower quality, but it's still better quality than the ones you were presenting. It's in focus, and
That's
it's
a
not
contradiction.
overexposed.
If it was better quality, you'd see the moons in better quality.
It's still better quality than yours because it is in focus and it is not overexposed. It is not a great quality. It is not a great quality camera. The pixel resolution is rather low. However, it is in focus and it is not overexposed. He even points out. He even points out the moons.
Focus, why can't we see the moons?
Because the pixel resolution is very small. Open your fucking ears.
So you're comparing a worse quality video to mine, but you're claiming it's better quality.
It's lower pixel quality, but it is in focus, and it is not overexposed.
It doesn't look like it's in
you
focus.
You can literally see the moons there. It is in focus. You can see the spherical shape of Jupiter, and you can actually see the moons there. Now, I'm pretty sure this video also has Saturn in, so let's have a look for that. There we go. And there's Saturn. Looks nothing like what you were showing. Nothing at all.
So, if you go back...
I mean, and here's the thing. This is just two. There is literally hundreds of videos of these things from amateur astronomers, right? If you have your camera in focus and you make sure it's not overexposed, you can get semi-decent shots. Like this. And like this. This is actual, decent pictures. Decent videos. Not out of focus nonsense done with a P900. Okay? That should be all that needs to be said there. Are you still there? Howard? Oh, nope. Did he rage quit? Oh, I hadn't finished with him. Let me check what's going on there. See if he's coming back. 2 secs. I don't think he rage quit there. I think he left by accident or his phone died or something. Oh, it's always... I mean, have you seen so much denial? Look, Howard, here's the explanation of why what you're seeing it matches the observations. No, it doesn't. But it's literally there. You can see how the light would go from the sun to the planet, to Earth. No, it doesn't match what we see. It literally matches what you saw, Howard. I mean, there's denial and then there's denial, Wow, 700 of you watching. Holy crap. You guys are awesome. Justin Frank says, I weren't fully grasping the depth of his stupidity. He thinks that you should be able to see Venus phases with the naked eye. That's why he kept going about Venus being only half lit. Yeah. He's back. Don't worry, he's back. Howard, where did you go? You back? Don't hear your audio. Try muting yourself and unmuting yourself. Testing.
How about now?
Yeah, there we go.
Sorry about that.
That's right.
I ran out of battery.
Yeah, I thought that was the case. I didn't say you rage quit because I thought that it was a bit weird time to leave. But
I've never rage quit. I've always left happy.
Right. So, what I would like you to do, all right, this is a little bit of homework here, and just work with me, is go and look for amateur videos of the planets. All right. Look for people using celestron telescopes specifically because they're really good. And I can send you a bunch of stuff from a friend of mine, Astronomy Live. who has done amazing images of all the planets in the solar system and many stars in our solar system. And none of them ever look like what you showed with your video. None of them ever look like that. When you have the equipment and you use it right, none of them ever look like those out of focus shifting blobs.
Like I was saying before I lost battery, I don't see how, when you can see the moons, clearly see all of the moons of Jupiter, and you can clearly see the whole halo of Saturn, and you can clearly see the phase of Venus in the video that I showed, which everyone can rewind and watch again on a big screen. That's not distortion, that's not out of focus, because it was much more detailed than the video that you showed. So I'm happy to come back and revisit this, and I'll find more video and you can find better video, and we'll hash it out and we'll see who's got the best quality video.
So here's another thing as well. You can't really see the phases of Venus with your naked eye either. That's, it's too small for that, really. But with a decent camera or a telescope, you really can. But look at this image, right? Look at Saturn, all right? Yeah, you can see the whole halo of Saturn, but that entire image is massively overexposed. Same as Jupiter, all right? Jupiter is massively overexposed because we know that Jupiter looks nothing like that.
We believe, we don't know.
So
you only believe what
there's
NASA
there's
have shown
Jupiter.
you.
No, this isn't NASA. There's Jupiter with an amateur telescope, all right? But that's not overexposed, right? And you can even see the strips of the atmosphere, right? And compare that to what you've got here. You can see that Jupiter is overexposed. There is more light on that than there should be because they haven't used the camera correctly. And this is Saturn. This is Saturn with an amateur telescope, amateur equipment. You can see the difference in the rings. You can see the stripes of the atmosphere. You can see the hexagonal shape at the North Pole. But compare that to what you've got, and it's extremely overexposed. Yes, you can see the halo, but it's massively overexposed. The whole thing is glowing ridiculously bright. That is not what you get when you actually look at it with decent equipment.
Which is what you would expect if it was emitting its own light as the ancients and wandering stars.
If it was, yeah, but then you can get pictures like this which show that it's clearly not emitting its own light. Clearly not, because there's shadows there. Things that emit their own light do not create a shadow on themselves.
How come we don't see any shadow on my video, which is supposedly overexposed?
You just answered your own question because it's overexposed.
Even if it was overexposed, you would expect the back part of the halo to be darker.
No, not if it's overexposed. No, if it's overexposed, you would expect to just see a blurry, bright mess. That's it. Right.
It wasn't very blurry though. I could clearly see the halo defined.
Yeah, but it was clearly overexposed. And when something's overexposed, the entire thing's going to look like that. But when you actually use proper equipment, the fact that we have images like this debunks you.
No, because that's an image. I'm showing a video.
Well, no, this is a video, and I showed you. This is a slow motion video, but then the other one I showed you is a real time video, right? So we've got this real time videos showing that it looks nothing like that. That it's not that bright.
Yeah.
And
Hold on. Go back a little bit. I love that picture of Saturn there. You see? Go back a little bit where you show us all the different angles of Saturn. There. Pause that. How come we never see that?
We do. At different positions, we do see the rings shift. Maybe not as much as that graphic shows, because we wouldn't.
From Earth. How come we've never ever seen another angle? It always looks like an eye in the all-seeing eye of Satan.
because it's on the ecliptic. Because Saturn's axis doesn't change relative to us, so we're always going to see it at roughly the same angle. But when you can actually see that it does. Wait. Let me finish. Yeah. So it's always going to be roughly the same angle, but we do see it slightly shift, right? If you do time lapses of it, you can actually throughout the night you can see the angle slightly shift based on where we are looking at it. That does happen.
I'd love to see evidence of that to support your claim.
But the main point here is that alone
never seen that.
debunks that. What do you mean you never see that? You're seeing it now. You're seeing it right now.
I'm seeing an image. It could be a.
This is a video.
No, I'm on about the image that just popped up on the screen where it's a straight line.
That's just someone putting a random graphic up. It's not relevant to the actual video.
A random graphic because it's not real. So here's my point. Does it look like an eye in the sky?
It looks like that, like we see.
Like an eye in the sky. And doesn't Saturn and Satan sound pretty familiar?
Who cares what words sound familiar? Saturn has... The name Saturn does not come from Satan. At all.
So Kronos being the god of time, no? That doesn't relate to Saturn, the planet? Or the
It certainly doesn't relate to
planet.
Satan.
Really?
Yeah. Kronos has nothing to do with Satan. So Saturn,
isn't the god of this world
Saturn was named for the Roman god of agriculture and wealth. So nothing to do with Satan, Howie.
Maybe in the esoteric or the exoteric narrative, but
no. That's what it was. Saturn was named for the Roman god of architecture and wealth. That's what it was. It was nothing to do with Satan, and it was named before Satan was a thing.
Surely you know that the Vatican have got a esoteric and an exoteric
I don't care about the Vatican. They're relevant to evidence for the shape of the Earth.
Well, you were just talking about Romans, so let's talk about the Vatican.
Roman god. Hold on. Roman gods are nothing to do with the Vatican. That is ancient Rome.
Yeah, and the Vatican is ancient Rome, Babylon disguised as Christianity.
No. The Vatican is the center of Christianity or Catholicism on Earth. It's nothing to do with the ancient god of agriculture and wealth. Excuse me.
No, but it does have a lot to do with Lucifer because there's.
No, it has nothing to do with Lucifer. Nothing at all. It is named after the Roman god of agriculture and wealth. Stop making things up.
No, I'm not making it. I tell you what, I can show you.
Do you have any evidence? Do you have any evidence that Saturn was named after Satan?
I'll make a presentation and bring it to you. Let's move on to the last video.
There's someone in my chat whose surname is Satanus. Megan Satanus. Is she a Satanist? Do you think?
No idea. I don't know her, and I don't know what her family got that name from. Might be all coincidence, but you know, be careful what mudras you use because you don't realise what frequencies you're amplifying and attracting or resonating. Yeah, you should.
Sorry, that's what I do whenever I'm listening to Maiden. Right. Right. Last video. I need to download it, so bear with me.
Sure thing. So while you're downloading it, this last video is just a teaser, a trailer. I've crammed it in 2 minutes so we can touch on the subject, but I would prefer to make a longer video of maybe 4, 5, 6 minutes and to come back on the show maybe next week and we could go in more into depth because it's getting pretty late as well.
Yeah.
But just to touch on it tonight.
Someone was asking me in the chat, so I'm just going to quickly show them this. They're asking how I download my YouTube videos. So just as a quick side, this is what I do, guys, right? So you get the video that you want. It's really, really simple. You put your cursor between the E and the .com and just type PI. So whatever the URL is, before the dot, type PI and press enter. And it takes you straight to YouTube Downloader to download that video that you've done. And that is the easiest way to download videos straight from YouTube, right? So there you go. Now we know.
Where do you put the PI, before the .com or before the YouTube?
just before the dot. Whatever the URL is for YouTube, put it just before the dot. So after the E in YouTube, just put PI and press enter, and it takes you straight to that, and you can download it.
Cool.
There we go. It makes some adverts pop up, but just close down that browser window and ignore it. There we go. 4 seconds left. Okay. Globe skepticism. Can you provide a reproducible photo or video of the landscape partially hidden behind, below the expected curvature for the distance observed, without optical illusions due to light refraction from atmospheric conditions? Right. Before you start, without optical illusions due to light refraction from atmospheric conditions. All right. How do we remove refraction?
We can't, but we can have conditions that favour less distortion.
Right.
And we can have conditions that make it very difficult to see. We can have optical illusions where boats appear to be floating in the air.
Yeah.
You know, there's many different optical illusions that...
Even... Right, here's the thing. Even when it's a clear day, right, near the water especially, you're still going to get extreme refractive conditions, all right? Even if it appears really clear. The refractive conditions near the water make it hard to determine exactly what we're seeing, right? And there's a very good reason for this, and this is something that I Can Science kind of misunderstood my point on. When you're near the surface of the water, there's a higher lapse rate. That means that the difference in refractive index from, say, the surface of the water to 5 meters up, right? The difference in that in that 5 meters is really high, right? So the lapse rate between 0 and 5 meters is extremely high. But when you go up further, say you go up to 200 meters, the lapse rate between 200 and 210 meters is going to be a lot less than the lapse rate between 0 and 5 meters, right? The higher you go, although the refractive index can stay, close to being the same, the lapse rate between two altitudes above the surface of the Earth, it is a lot less the higher you go. That's why you move away from the water to do these observations, and it's why I present pictures to you like the one that Miles Davis took, which are 200 meters above the surface of the Earth. So the best way to remove the refractive conditions that can distort what you're seeing is to raise your altitude. Do you understand that?
Well, like I tried to say last week, you could also take an observation over land near to the coast so that you know that it's level with the ocean. So you don't have to make an observation over water. You can make an observation along the coastline so it's not over water, but along the coastline you know it's next to water, and as water tends to be level, you can trust that the water's flat.
So even over land, the lapse rate is going to be higher nearer the surface than it is further away. Obviously, when you move away from the water, that lapse rate isn't quite as high. But even over land, the lapse rate between sea level and 5 meters is going to be greater than lapse rate between 200 and 210 meters, all right?
You know this refractive index you keep talking about? This refractive index you keep mentioning?
Yeah.
Can you admit that they're just calculations that have been made on the assumption that Earth's surface is curving?
No, absolutely not.
Hold on. Just to make my point, can you admit that those refractive index calculations have been made on the assumption that Earth's surface is curving, and that they could be all based on a level playing field, but they've just come up with these figures to explain why we see what we see? Can you admit that they're just calculations?
No, because that's not true. Okay, refractive index is nothing to do with the curve. Refractive index is to do with the temperature and pressure of a particular medium and what will happen to the light when it's going through that medium. All right. Hold on. Let me finish. That's nothing to do with the curve of the Earth. All right. What we know is that there's a gradient of pressure through our atmosphere, okay? We know that's a fact. So that we can see that when light goes through that gradient, especially when the lapse rate is higher and the change in refractive index is the highest, closer to the surface of water or whatever, we can see that as light goes through that gradient, it changes. It changes direction, right? The curve of the Earth is something that happens because the refraction going around the curve of the Earth is something that happens because the atmosphere follows the curve of the Earth. But the calculations aren't based on that. The calculations show that to be the case. There's a difference. It's not going, oh, well, this is the refractive index, let's make up some calculations for it being curved. We know what the refractive index is, we know what light does when it goes through a medium, and when we make observations, we can see that that medium happens to be curved, and the gradient is also curved.
How can you measure that?
By measuring the surface of the Earth, by measuring the the lines of sight, by measuring the pressure of the atmosphere at certain elevations, by measuring the temperature of the atmosphere at certain elevations. And we know that when light goes through a medium, that medium will have a particular refractive index, right? So if we were to follow that refractive index along a line, we find that that line happens to curve with the surface of the Earth. That's just what we find from observations. That's not mathematically implying anything. That's just what the observations show us to be the case.
Well,
and when we map that out, when we mathematically model that out, it matches reality as well.
So it does get mapped out mathematically to suit
afterwards
your
from the observation. No, not to suit our model. We mathematically map out the observations, and it matches the model. We didn't put our model onto the observations. The observations just happen to match our model.
So when light bends, different spectrums of light would bend differently, just like
What do you mean different spectrums?
Sorry, different frequencies of light in the electromagnetic spectrum would bend at different speeds, just like we were saying about two cars
different
going around
different wavelengths refract slightly differently. Yes, there's you can use things like microwaves. You can use things like microwaves, which have a much shorter wavelength, which don't refract as much as things with a longer wavelength.
Right.
But they still do. But if we know the wavelength, we know how much that wavelength will refract through a certain medium.
Right. So to not lose my point, just like a car on the outside and a car on the inside will take a bend differently, yeah? So light bends when it gets refracted. When light bends, the different frequencies of light would bend differently, and we would get a distorted image. But when I show my observation of the streetlights 20 miles away, you and Michael can turn around and say, yeah, well, the lapse rate just happens to be perfect for the light to bend and everything to look flat, but it's just an optical illusion. It's really light bending. Yet we happen to see light bending.
We do see that. We do actually see that.
Doesn't matter the time of day, it doesn't matter the time of year, it doesn't matter the distance. For some reason, it seems to always bend perfectly. And even if there's things behind the skyline or the city lights, they bend also at the perfect amount, and nothing gets distorted. Even though there's different wavelengths, even though there's different distances, the light source can be in a different place. Somehow, light refracts, but it doesn't distort.
So here's the thing: the difference in wavelengths between the ultraviolet and infrared, the wavelengths of light that we can see, the distance of the wavelengths is so little that you wouldn't see that much distortion when you look through refraction, but you do see some. It's called chromatic aberration. There are times where it appears almost as though the colors are separating, but that depends on that's extreme refractive conditions. But the difference in the size of the wavelengths between the red and the violet side of the spectrum is very small, so you don't tend to see that much distortion between the colors. It is something that happens, but only under extreme refractive conditions. Again, when you look at the actual maths behind refraction, and I would suggest going to Andrew Thomas's Young website. I'll send you a link to that. He's the world's leading expert on refraction. He's done so many experiments and stuff. He explains perfectly how when light is going through a medium, even a flat medium, it would still tend to bend down slightly because of the way that light's interacting and going through that medium. But we do see the distortion, but only in extreme times. But all the refraction we see matches what we expect to see, right? there is no way to remove refraction completely from the observations. So we have to instead understand refraction. It's as simple as that. You know,
Yeah.
your observations
As you say,
of the lights 20 miles away, right?
Refraction would exist on either surface.
Yeah,
Down
absolutely.
to
100% refraction would exist on a flat Earth. 100%. However, it would
Or a
be
concave.
refraction would be very different on a flat Earth as to what we see in real life. In fact, Andrew Thomas Young has got an entire page just about that. Now, we can't ever remove refraction. That's just not something we can do. So we have to understand what refraction does and include that in our observations. Now, your observation of the lights, even though I say that you're not looking at what you think you are, I think you're looking at lights on the hill slightly behind it. Even if I accept the premise that those lights are at sea level, that observation is what, 19 miles?
20 miles should be 80 meters of vertical drop.
Right, so, no, but when I looked at it on Google Earth, it was 19.4 miles, right? So we'll say 20 for whatever, right? Now, 20 miles on Earth is less than 1/3 of a degree of curvature. Because on Earth, if the Earth is the size we say it is, 1 degree of curvature equals 60 nautical miles or 69.1 statute miles, okay? So 20 miles would be less than 1/3 of 1 degree. Do you agree with that?
Do you agree that it add up to 80 meters?
Wait, hold on. Don't answer my question or a question, right? Do you agree that on Earth, if it's the size we say it is, 20 miles is less than 1/3 of 1 degree?
I'd have to do the math, but I have done the math on the meters.
Right. One degree is 69 miles, right? 20 is less than 1/3 of 69, right?
Just for the sake of argument, I'll assume that.
What's 3 times 20? 3 times 20 is 60. So we know 20 is less than 1/3 of 69, right? So it's 20 miles is less than 1/3 of 1 degree of curvature on Earth. Standard refractive conditions on Earth, even though there kind of really isn't a thing, but what we expect as kind of the average refraction gives us about a degree of curvature, right?
Well, is that what we expect based on the belief that Earth's surface is curved?
It's based on the measurements of Earth's surface being curved, and it's based on hold on, right? It's based on our known understanding of the laws of refraction and what would happen if the Earth was the size we say it is, right? And it matches the predictions. Okay? If Earth is if Earth is the size we say it is, 1 degree of curvature is 69.1 statute miles. So 20 miles is less than 1/3 of 1 degree of curvature, which for refraction that we expect to have is no problem, right? It's just no problem.
But it adds up to 78 meters of vertical drop. Yet the tallest building is 96 meters.
You're using the drop calculations wrong. We can go through the maths another time.
Water level, which my observation is, because we're looking under the platform of the cable ski. Which
you
is
weren't
about
at water
half a
level,
meter,
though.
Huh?
You weren't at water level, though, were you?
Yes, I was, and I can make a better observation now. I've got a better.
How far above the surface of the Earth? How far above the surface of water were you?
To see the street lights, and you can check this on Metabunk, you should have to go to 25 meters altitude to be able to see those street lights. I can show you a screenshot from Metabunk that I did 5 years ago.
So
25 meters.
You didn't actually answer my question. How high above the surface of the Earth was your observation?
About 50 centimeters.
50 centimeters, so about half a meter off the surface of the Earth.
Yeah, I nearly got my camera wet.
Right, let's go to Metabunk right now and have a look. Because I don't trust your calculations there.
That's fine. And while you're looking for that, we can also see the hills in the background, and we can even see Alicante City further back than that, which is even further than 20 miles away. So we can see much further than 20 miles away, and there's no vertical drop whatsoever in the hills behind San Juan or the city of Alicante behind the hills behind San Juan. So yeah, we can see over 20 miles away. It's just that the street lights are about 20 miles away.
Okay, with the refraction approximation, standard refraction, Metabunk says that there should be a refracted drop of 69.69 meters. So how tall is the tallest building there?
96.
Right, so we can see, seeing some of the building is what we expect, right?
But we see all of the buildings, even the short buildings.
You really...
And the street lights
don't
along
in that.
the bottom
Okay.
of the buildings.
So, did you do... Oh, wait, that's at 6 foot as well. So let's...
So yeah, it's very strange that we can all see the street lights 20 miles away and the city behind San Juan, Alicante City, which is probably 25, 30 miles away.
Yeah, and again, that matches what we would expect to see with refraction, as this says here. With the
refraction calculations that are based on a curved surface,
which are based on measurements and are known laws of refraction. That's what we expect to see, all right? But again, the best way to actually do these observations is you're still looking over water. The best way to do that is to move away from the water, go high up, right? And I can show you observations from high up that show that the Earth is curved.
Well, put my video on, because I've got two of your they're not really your observations, are they, Craig? Let's be honest. That's what
they're observations that I use, and ones that I've checked.
It's just 2 minutes, this video, so if I can just speak the majority. I'm telling people to make their own observations because I've made many, and every time I make an observation I get the same results. You get results like this when there's optical illusions because of strong atmospheric conditions, yet you can go back to the same place and you can see much further. Look at the landmass on the left side of the screen. We shouldn't see that landmass, but we do.
The landmass was floating.
Let me keep talking, and then we can revisit it. If this was the curve of the Earth, then surely there'd be curve going left to right as well. But
no,
there isn't.
That's a straw man.
So this is please let me just keep talking. This is obviously perspective, because now we're looking 52 miles away and we can see the buildings from pretty much top to bottom. We shouldn't see any. This is 30 miles away at water level, as seen by the plant next to the water as the camera zooms in. So we can see 30 miles away at water level.
That's not water level. That is not water level at all.
Now, if I may, here we can see that the horizon doesn't drop from eye level even when at 39 kilometers high, and we can see that there's lots of different ways to add the curvature up, but there should be approximately 18 meters for 20 miles. Lasers prove that there isn't. My observation, which everyone can make, proves there isn't. A rail gun which uses an RF pencil beam for over 100 miles, there isn't. And your observations, which aren't your observations, could be optical illusions, because we can all see Mount Everest from 120 miles away when we're at land, and we can see Mount Everest from Dubai when we're in an aeroplane. Here, this debunks your pictures. It only takes a slight change of angle, and we can see that those trees in the far are much higher than this boat. Obviously, the boat is on water, yet it looks like the boat is higher than the tree line due to a slight change in angle.
Yeah, but they weren't the same distance. They weren't the same height, which is what my picture shows, and it's what everyone seems to ignore.
It's not your picture, and this is what
it's my friend's picture of something just down the road from me. Right, so it's the observation I'm using, and anybody can go and repeat this. I don't care if I didn't do it myself. That means fuck all. All right, and here's why. Hold on. Here's why your debunk there was fucking useless. All right. So let's go back to your thing quickly. All right. So the top of this line here and the top of the trees, you're saying the angle makes that change. Right. Fair enough. But here's the thing. The top of that.
So
hold on. Let me fucking. No. Stop, Howard. Howard, stop. Shut up, Howard. Howard, let me finish. Let me finish. Let me finish my sentence.
You don't let me
Thank
finish.
God.
What did you-
I'll
Calm
come back
down.
to you.
What did you agree
I will come back to your question once I'm done.
But what
No,
did you
no, 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 no,
disagree
no.
with?
I'm not listening to you. I am going to finish
I
what I'm
wanna
saying.
clarify.
I am going
Well,
to
just-
finish what I am saying. Do
what
not
is it you
speed.
disagree
I'm
with?
going to mute you. Howard, if you speak once more, I'm going to have to mute you. Let me finish what I'm saying without interrupting, please. Thank you very much.
But you did agree. You did agree, though.
Let me finish what I am saying without interrupting, please. Right?
But you did agree.
Let me finish what I am saying without you interrupting, please. Thank you very much.
Yeah, just want everyone to
Don't
realise
don't
you
talk.
did agree.
Don't talk. Don't talk. Just don't talk. Just don't say it. Just don't say anything.
But you did agree.
There we go. There we go. You've managed to stop speaking. Well done. Right.
You
So,
did agree. You did agree.
so oh my God. No, okay. Once more, Howard, I will have to mute you. Please do not speak for the next 30 seconds. Thank you. Right. The top of that glass there does appear to
Yeah.
change angle with the trees in the background. However, that is not a fair comparison to my picture, because my picture has both the camera and the red line, which is in line with the top of that pillar, at the same height. The same height. These two things, the top of this glass and those trees, are not the same height. So that is not a comparison to my video. The camera is at 210 meters above sea level. 210 meters above sea level. That tower in the middle, the top of it, is 210 meters above sea level. That means that no matter what angle changes, those two will always be in line. Always. Because they are the same level. Which means that anything behind that line has to be higher than 210 meters if the Earth is flat. Do you understand how your picture, your video here, Howard, is not a fair comparison to my picture? Does that make sense?
I feel like my video is proving that with a flick of the hand, flick of the wrist, you can change the angle, tilt a tiny bit, and it can give a different optical illusion that the tree line is lower than the window when it's obviously the other way around. So I don't see how we can all take your word for it.
I've got proof for you right now. If you just give me 1 second to find the picture.
If I can just finish what I'm saying so that you know what I'm saying. Yeah. One, we've got to take your word for it of the height. Two, we've got to take your word for it that the angle wasn't tilted up or down to get the desired optical illusion. And three, I'm showing a video that literally shows you can do it. You're showing an image. I'm showing a video.
Yeah,
again,
but again,
like with the planet, I'm showing
your video. Your video is
showing
not
low quality images and low
your
quality
video
videos.
is not a comparison because the line of this glass is not the same height as those tree lines. Therefore, it is not. Therefore, it is not a comparison. Now, right? Before you go on to before you go, hold on. Before you go on, let me show you something. All right, my good friend Tommy Gronvild did a direct debunk of your claim. Okay, so let me show you. Right. So as we can see here, we've got his camera set up. Right. It's looking along this level line. Right, you can see that it's level because the water is the same on both sides. All right.
Yeah.
And when the camera looks at it, you can see that the level line matches. Okay. So because they're the same level, they both match with this line. Do you agree with that?
In this picture,
so we can say that is eye level, and we know that both of those water levels are the same because it's water, and water tends to find its level with an open container like that, right? However, what Tommy did was he changed the angle of the camera, as you can see what he's doing here, right? When he changed the angle of the camera, you can see it's pointing up, right? However, even though it's pointing up, the two levels still stay exactly the same, right? So the level compared to each other, because we know that is the level, stays exactly the same. And then he did it the same. He pointed the camera down, looking along the level line. And after pointing the camera down, you can still see that the two levels were the same. So changing the angle of the camera when you've got something level, will not change the angles relative to each other if they are level. Does that make sense? Here's a composite of him showing the up and the down that he did. That shows that you can have something and change the angle of the camera, but as long as the center of the camera is level with the things that are level, no matter what the angle is, those level things are still going to appear level with each other.
Yeah, but like you could see on my video, if it's slightly lower or slightly higher while it's tilted, it can really, really change that effect dramatically.
If it's not level, correct. If they are not level with each other, like in your video shows, right?
Yeah.
The top of this here. Hold on. The top of this glass is not level with the top of these trees. All right. In fact, I would bet the top of those trees is about 20 times higher than the top of this. So of course, this changing angle will drastically change what you see in the distance because number one, this doesn't stay level with the camera. The glass doesn't stay level with the camera, and the glass is not the same altitude as those trees in the distance. We know for a fact that if the camera is level with 2 points, no matter the angle of the camera, those points will still appear level with each other. Okay?
Yeah.
Which takes me back to the image I used from my good friend Miles, taken literally less than 3 miles away from my house.
But you haven't taken yourself, so you're believing what he's done is honest. And
hold on. This is from a video, all right? This is not just a picture. This is a screen grab from a video. And in the video, he shows you that he is next to a surveyor's marker that shows he is at 210 meters. And he puts his camera at 210 meters. Okay?
Yeah. 210
meters, the top of the bridge, 210 meters. That means you've got level. That means, as we showed with Tommy, they will, no matter the angle of the camera, they will always stay the same. They will always stay in level with each other.
Well,
and that goes on. That goes on for further and further and further. Anything that is the same height as the camera and these two levels, no matter the angle, if it is the same height, Howard, will always stay
the same height.
I haven't finished my point, right? We see that. Let me finish my point. I'm nearly there. Okay. If the camera and the things we are looking at are all the same height, regardless of the angle, they will be level. Which is the issue with this picture, because the camera and the top of that tower are 210 meters. We know those hills in the background are greater than 500 meters, yet they fall below the eye line of 210 meters. Perspective would not make that happen. Perspective would make it go into the red line. This is impossible if the Earth is flat.
Right. So, as we know, it only takes 1 or 2 centimeters to make a massive difference, as seen on that boat video. So even if
not 1 or 2 centimeters. That's true. Again, the boat.
Let you yap on for ages. But
you've just misrepresented it straight away. The glass and the trees are not the same height, so it is not a comparison.
I'm trying to make a point, and I'd like to finish what I'm saying before you interrupt me. Right?
Go on.
It only takes 1 or 2 centimeters to make a drastic difference. So even if he is at 210 meters, he only has to go 1 or 2 centimeters higher, and he can make it look drastically different, or 1 or 2 centimeters lower, and he's still 210 meters. Just a few centimeters lower or a few centimeters higher can make a massive difference, as this video proves in the boat.
Well, the video in the boat doesn't prove that, because it's not a few centimeters, because the difference between the top of the glass in your video and the trees is way more than a few centimeters. So this is showing something completely different. Basically, Howard, basically, this is a straw man of my position, because it is not my position. It is not my position. No. It is not my position. My position is when the camera is the same height as the thing you are looking at, that is when you can do this observation. Your camera is neither the same height as that glass or the trees in the background. Therefore, it is a straw man of my position, and I will not respond to it further.
Well, I think I've made my point. Well, I've tried to. That I'm talking about the glass and the camera. If the glass is 1 or 2 centimeters higher than the camera, or if the camera's 1 or 2 centimeters higher than the glass, it makes a massive difference to what you see in the background. And I'm pretty sure it's the same for this observation as well.
Not if they are level with each other, no.
A few centimeters in the right atmospheric conditions, wow, you can make some amazing effects. Because this is one observation, yet I can show you many that show the opposite. Like I did, we can see the Himalayan
you never show me an observation that is the same as this. You have never ever showed me an observation with a camera the same height as a point in the distance. And here's the thing, right, Howard? Again, this isn't just a picture. This is a screen grab from a video. In this video, he turns 180 degrees and makes an observation looking the other way. And it's the same kind of thing. You've got a monument, Hope Monument, which is 210 meters, the same as the camera. And then you've actually got hills that are further off that are actually a kilometer in elevation that still appear below that 210 meters. An impossibility if the Earth is flat.
Not an impossibility.
Absolutely an impossibility.
Possibly just an optical illusion due to atmospheric conditions and perspective and a lot of other things.
So, as I explained, perspective wouldn't do that because the camera's the same height as the observation point, so no, perspective wouldn't do that. We have moved away from the higher refractive effects because the lapse rate is a lot less, so refraction is not going to remove over half of those mountains in the distance when you are 210 meters away from the surface of water.
In your opinion, although
no, according to the laws of refraction.
Law, you just said that refraction calculations are based on an assumption that the Earth's surface.
I never said that at all. You said that. I said the specifically opposite of that. There is laws of refraction. That is a thing.
Yeah, and they have to be updated when they're proven otherwise. So, can I see water in that image, Craig? Is that a large body of water and a bridge going over water?
Yes, and we're 210 meters above it, away from the large lapse rate.
But we can still see there's a large body of water that could be affecting the observation dramatically.
No, the light isn't coming from the water. With the observation we're looking at, we are looking through our eye level towards those towers, all right? And the refractive conditions there are going to be very different to the surface. You are not going to, hold on, you're not going to get the large lapse rate that you get near the surface of the water. We are 210 meters away from the surface of the water, away from the large lapse rate, meaning the refraction will be a lot less.
But not only can I see a large body of water that's very far ahead of us as well as across.
That's the first or fourth.
Hold on, Craig, please. I can also see that it's a very foggy day because I can't see the mountain details very good in the distance. Yet in the picture that I showed on my video where you can see Mount Everest from 120 miles away from Nepal, yeah, that was 120 miles observation, yeah, with better conditions than what you're showing me. Yeah, better conditions. You're showing me
even if it's foggy, you can still see the hills. So the fog is irrelevant.
You're showing me a video. You're showing me a screenshot of a video that was taken on a foggy day and telling me that there's
Who cares that it's foggy? Fog is not refraction. Fog is not refraction. Okay.
Fog causes refraction. Though,
fog does not cause refraction. No.
Oh, so having water vapor in the air wouldn't cause.
It doesn't cause refraction, like when you're looking at the refractive conditions are away from where the lapse rate is changing, and even if there's fog up there, let me finish my sentence. Even if there's fog up there, the lapse rate is still going to be a lot less, meaning the refractive conditions are lower.
But there is a lapse rate, yeah.
Yeah. Can you define lapse rate for me? I've told you a few times.
Well, my point is, when you're saying that an observation over water gets distorted because it's over water, and I'm saying, well, if there's fog in the air, that's going to cause refraction and different optical illusions as well. You're like, no, it won't. No, it won't. Well, make your mind up, Craig. You can't.
No, I didn't say no. I'm trying to explain that the lapse rate won't do what you're saying it would do up there. I'm trying to get the actual video for you. So if you give me 1 second.
it seems to just always be your way, you know. It's like, yeah,
Well,
there's a lapse rate
it's
when-
amazing that physics happens to fall my way. Yes, that's just a thing, you know.
It's like when I was on the playground in infant school, you know, and the other kids always got an answer like, yeah, well, I'll get my dad. Oh, yeah, well, I'll get my granddad. It's like you just keep
It's
making
nothing to
things
do
up as
with
you
my
go.
dad or granddad. It's just facts.
No, mate, because one minute you're telling me that light refracts in any shape, Earth, and it always refracts no matter how good the atmospheric conditions are, and now I'm showing you that your image is very foggy, and you're like, yeah, but that wouldn't make light refract.
It's not foggy. That's not fog you're seeing. It's just like the time of day and stuff. Like,
yeah, exactly.
And
In other
fog
words,
doesn't
it's
cause
selective
refraction in the
foggy.
way that you are saying. You know, you're just trying to make something to change this observation. But that doesn't stop the observation being what it is.
What is this observation? About, what, 40, 50, 60 miles or something?
The hills are about 40 kilometers in the distance.
Great. Well, I've just put an image in my video that was 120 miles away, and the mountains are way clearer with 120 miles distance than your foggy crap.
It
So
doesn't
stop
matter
calling
if
that-
it's clearer. The fact
it
that the
does.
clarity isn't refraction. They aren't the same things.
What are you talking about? If the
Clarity
air's full
is
of
not
the-
refraction. I literally explained to you earlier that the days that you have really clear views, there's actually tends to be more refraction going on. This is just a fact.
So you're telling me that light doesn't refract more when there's more particles in the air, when the air's denser with
No,
water vapor
the
and pollution
refraction,
and all that. You're telling me
the
that
amount light
doesn't
bends,
refract more.
the amount light, let me answer your question, the amount light bends is due to the difference in pressure and temperature between two levels. That's what
Yeah.
causes the refractive conditions, all right? That isn't even fog, it's just, you know, bad lighting and stuff. It's not
Yeah.
like, it's not a bunch of water particles that are causing light to bend crazily. That's not what this is. I'm trying to find the actual video for you so that you can see. So if you give me
Have
2
you,
secs.
have you taken the temperature and the pressure gradients for this observation, Craig?
I'm sure that he did when he did it up there.
But you haven't yourself, and you haven't checked his. So he hasn't measured the lapse rates like you're always telling me I should.
Again,
Well,
anyone
isn't
can
this a
repeat
double-
this. Anyone can repeat this observation, and the point is that
Anyone-
the point is he is away from the surface of the Earth where the lapse rate is the most.
Yeah, but whatever rate you want to measure, he hasn't measured anything. Yet
No,
you're always
he
making
moved
out we have to
away.
measure it. It's a
He
double
moved
standard.
away. He moved away from it, so he didn't have to do that. That is the point.
Obviously not. It's a foggy crap picture, Craig, of a foggy
You can
crap
keep
video.
saying it's a
I'm
foggy
saying-
crap picture.
Look,
It's not
Craig,
fog.
Craig, let me-
It's a
let me get a
video.
word in.
It's a video that shows that the Earth is not flat. There is not
No,
fog.
shows-
It is just
shows an
bad
optical
lighting.
illusion. It shows an optical illusion on a foggy day. Great. But my
Yeah,
point
no, sorry.
is-
There is no refraction that will make over half of a mountain disappear when you are 210 meters in the air. Refraction does not do that.
Supposedly. We've
No,
just
not
gotta take his
supposedly.
word.
Not
We've gotta take
supposedly.
his word.
Not supposedly. Not supposedly. It's a fact. Oh, why can't I
What?
find
You
the actual
weren't
video?
there. You weren't there. So we're taking this guy's word for it. that
He
was
recorded it
honest.
on video.
So what? I can make a video of Spider-Man. It doesn't make him real, mate. I'm telling people to make their own observations.
Yeah, and anyone
you're
can go and
telling me
repeat
that
this.
Oh,
Anybody can
Craig,
go and repeat this. Anybody can go and repeat this. Anybody can go and repeat this.
Don't get your knickers.
Anybody can go and repeat this. End of story.
Woo! Let me get a word in, Craig.
No,
So here's the
anybody can go and repeat this.
Craig, you sound like a broken record.
Anybody can go and repeat this. Why aren't you
Anybody
acknowledge the
can
fact
go
that
and-
anybody can go and repeat this? Acknowledge that.
Yeah, and guess what, Craig? Anybody can repeat my observation when they come to Benidorm and they can see the streetlights of San Juan.
Yeah, which
20
matches
miles
them, and again, that's no problem in our model, so there's no issue with that.
No
It matches
problem.
what we expect to happen. Yeah.
Every day.
Yep. Yeah. Again, less than 1/3 of 1 degree of curve is no problem on any day.
No matter where the light source is, no matter what the temperatures are,
no,
no matter
exactly, Howard. No matter what, 1/3 of 1 degree is no issue for our model. The observation you present matches what we expect to be able to see.
So
End of story.
seeing around, let me speak. So seeing around a corner, yeah, being able to see somebody stood behind a wall, 80 meters curved around.
Yeah, that
is
happens.
normal. Is
Yeah.
that normal? Yeah. Have you ever
That is
seen
what
around
refractive
a-
conditions show would happen. Yes, absolutely.
Have you ever?
Would you
have
like
you
me
ever
to?
been able to? Please shut up a sec. Have you ever been able to see around a corner, Craig? Ever? Have you ever
Yeah.
actually been able to see around a corner?
Yeah, with mirrors and stuff. Absolutely.
But we haven't got any mirrors to see
Yeah.
the streetlights 20 miles away
Yeah.
when they're supposed to be 80
do-
meters below us. 80 meters below us.
One
Yet we
sec.
see the streetlights along the beach from
Let
20
me-
miles away every day.
Let me just show
Everyone can
you.
see them.
Let me show you the light actually bends the way that we say it does with refraction. Just give me 1 second to
Yeah,
get
yeah.
the video.
Have you ever been to Phuket and looked
No.
at Krabi, the PP Islands?
And does that fall outside of predictions of our?
Well,
Excuse
it's
me?
more than 20 miles away. And I tell you what else, mate. If you go to Denya, the port of Denya, you can see the island of Ibiza, 111 kilometers away. And I
Can
tell
I-
you what, mate.
Yeah,
if you go
and
to Blackpool,
have you checked
hold on.
Have you checked
Hold
if
on.
that falls out? Have you checked if that falls outside of what you should be able to
Yeah.
see?
Yeah, otherwise I wouldn't be talking.
No, you
So
haven't,
I'll
have
finish-
you? You didn't check what we should be able to see with refraction, did you?
Craig, shut up a second and I'll finish talking and then you can ask me a question, yeah? If
You don't
go to
answer, so there's no
Blackpool,
point.
If everyone that's watching just checks for themselves and stops believing people like him, we'll get on a lot better with science.
I don't ask people
So
to believe me. I ask people to
Hold
do
on.
things themselves.
I'm telling people to
Blackpool,
either
here
go
we go.
Denya and look at Ibiza, or go to Blackpool and look at the Isle of Man, which is over 100 miles away. And guess what? You'll see the Isle of Man from 100 miles away from Blackpool. So,
Yeah, and here we go. No problems with what we expect to see on our model. Right, so I'm just going to show you how refraction actually works, and then we're going to get into Q&A, okay?
you're like a model that has plastic surgery whenever it suits you, mate. You just keep changing
Yeah,
it
no,
up.
your ignorance of what a model is irrelevant. Okay, so here we see a can. This can has 3 bits of plasticine on: yellow, red, and green. Do you see those?
Yeah.
What order
Blue.
are they in? It's clearly
And the
green.
red gets distorted when it bends
What
around.
what
the
what
curve,
order?
doesn't it?
What order are they in?
And it gets distorted.
Yeah. So
when it
what
bends-
order are they in, Howard? Just I want you to confirm for me the order of the colours. What's at the bottom?
Yellow.
And then what's next?
We can all see what colour it is, Craig.
Yeah, I just want you to say it. What's next?
I'm not playing this stupid game.
Come on,
because
it's-
it distorts.
Red
It
and then
distorts.
green.
Play
Okay,
the video
so
and we'll all see it distort. It
shows that
clearly
refraction does what we
distorts.
say it does. Yes, we're making extreme
Yes,
refractive
yes.
conditions. Yes,
Yes,
don't talk. I'm talking.
Don't say something that hurts my ears.
I'm
like it
talking.
distorts.
I am talking.
It distorts.
Right, I am talking.
Does it?
If you
Yeah,
could,
does
right, Howard, I will talk through the video. You are going to listen. Okay?
Does
So-
it distort though?
I'm going to talk through the video, and you're going to listen. Right?
But it does distort.
I'm
You'll
going to
see
talk
it
through
distort.
I'm going to talk through the video, and you're going to listen. Okay?
And I'll see
Right.
it distort.
So here we go, right? We've seen the can, and we've seen him place the can behind the horizon of this curved thing.
Yeah.
Now we are going to place some extreme refractive conditions, which will cause all
Yeah.
sorts of distortion. But it will also show
Yes.
one very important thing. It will show one very important thing, and that will show us that we can see around the curve.
But distorted.
Yeah,
Distorted.
absolutely it's distorted. That's how we're seeing around the curve, Howard. So, yeah,
Distorted.
absolutely it's distorted. That's how we're seeing around the curve, Howard.
But we
So,
don't see the cities.
Howard, right, I'm going
of
to mute you. I'm going to
South
mute you for 2 minutes because you can't seem to keep quiet whilst I'm trying to present this. Do I have to mute you, or can you be quiet for 2 minutes?
You've already admitted it now.
Do I have to mute you, or can you be quiet for 2 minutes?
Be quiet. You've already admitted
Okay,
it's
right. Well,
just-
please, all right, do not talk. Thank you very much. Right. So
Fine.
we've got we've got this green bit behind this curved horizon, right? We're going to place some... I'm asking you to please be quiet. Thank you very much. We've got this green bit of plasticine. We've got this green bit of plasticine on the horizon of this curved item. All right? Green plasticine on the horizon of this curved item. Now we are going to induce some extreme refractive conditions, which will do all sorts of things, including distortion, including squishing. But what it will show is that we can absolutely, with refraction, see around the curve.
Yeah.
So here we go, applying the refraction.
Distorted when it comes, and that's blue.
There we go.
Clearly...
There we go. So in the area where he has created a large lapse rate, which is from there to there, you can quite clearly see it. This area now has a much larger lapse rate than this area. This area's lapse rate is much bigger than this area, right? So the area where the lapse rate is larger has allowed us to see around the curve. The red's not there because the red is hidden behind the curve. We increase the lapse rate, and the area where the lapse rate is increased, which you can quite clearly make out where the lapse rate is increased. You can see where the distortion is happening due to the lapse rate being increased. That area allows you to see around the curve, right? So I'm going to ask you a yes or no question, Howard, and I would like you to answer it yes or no. Are we able to see around the curve of this horizon? Yes or no?
Distorted, yes.
No. Just a yes or no. Are we able to see around the curve of the horizon?
A distorted.
Yes. It's just a yes or no question.
No, it's a distorted yes.
Where the lapse rate is, there is some distortion, absolutely. However, the question is a yes or a no question, Howard. Are we able to see? Yes, I just want yes or no. One word.
I don't care
right?
What you want.
Are we able to see around the curve?
Be honest. It's distorted.
Are we able to see around the curve? Yes or no?
Distorted.
Yes, we are. You have said yes. That is all I care about. You have been debunked. Refraction allows you to see around the curve. Game over. You lose. End of story.
Can you show me a experiment that can bend light without distortion? No.
Yeah, absolutely.
So how come? So let me speak. Craig, listen to you.
We absolutely can. Right. I said that after that we would be going into Q&A. So instead of going around in circles with you not understanding physics, let's just get into the Q&A, okay?
Yeah, but you do admit that was distorted.
I admit where the lapse rate was, there appeared to be a major amount of refraction. The reason let me just clear this up because you can't get it into your thick head. The reason.
Can I get a question in after? After, can I get a question in?
You can have one question afterwards. The reason there is that particular amount of distortion is because of the disparity between the lapse rates. Okay, where he pours the gas onto the container, for the few millimeters above the container, he changes the lapse rate more than he changes the lapse rate a little bit higher. So between those two areas, there is a large disparity, which is why there appears to be that distortion. But in reality, we do not have that disparity so, exclusively. There is a gradient that slightly changes. So that is an exaggeration of what we expect to see. It just shows the point that refraction allows us to see over a curve. That is it.
Yeah. Okay. So, how come we can see cities, skylines, and mountains, and cities behind that city, and they are not distorted at
because
all?
There is not such a disparity between the lapse rates. There is not one point of a lapse rate here with another point of a lapse rate here. There is just a steady gradient in the world, in nature. All right. What we saw there was inducing extra refractive effects by severely increasing the lapse rate closer to the count. However, just above that, as you could see, there wasn't the gas wasn't there. It had dispersed. So the lapse rate wasn't changed with that bit above. So that's why there was that distortion there. In reality, there is just a gradient, a very gentle gradient, that means that there won't be that distortion that we saw there. Okay, that's your question answered. That's your question answered. It's not convenient, it's just the fact. It's just the fact, right? So anyway, we're going to go into Q&A now. We're going into Q&A now, okay? Howard, I answered your question. I answered your question,
No, you haven't answered it properly because you didn't listen to the question. Tall buildings, short buildings, and buildings that are very far behind, none of them get distorted.
I just explained why, and actually they do get distorted quite often.
No, not in my videos, mate, and not in my observations, and that's why I'm telling people to make their own. Don't believe
actually,
me.
I've literally looked at your observations, and there's quite a lot of distortion. But anyway, we're going to go into Q&A, okay? Thank you, Howard, for hanging around. You need to learn to listen. Takos Yanis, been a member for 2 months, says, what do you get if you lock 10 flurfs in the closet for 24 hours? 11 broken flat earth models and 2 dead bodies. Are you kidding me? He's been a member for 4 months, says, if Harold has stayed long enough to hear this, then Harold, I am impressed. He did. Be impressed. Osimo for €4.99. Does this skeptic still thinks that the moon emits cold light?
I never said that it did. I said it might retract. I don't know how it works. I just know that if you hold a magnifying glass above the water, it will manipulate the effect even stronger.
No one has ever shown that to be the case.
You've never tried it, Craig.
No, I literally did try it in my experiment that I did in my Discord. Magnifying glass in the kitchen. I bought a magnifying glass specifically for that and used it, and it made absolutely no difference to the effect. There is not one bit of evidence anywhere ever that shows a magnifying glass would increase the cooling effects of the moon. That is not a thing. And I did an experiment to demonstrate that.
What did you do it on? Water? Or
yes.
Did you do it on a... Really?
Yes. Sorry, Howard, do you not remember the month-long experiment I did to disprove your nonsense?
Well, the thing is, if your intention was to disprove, then that shows that you have a bias already. No, that's what science does. Science experiments are intended to try and disprove something. That's how science works. Yeah, but you went out of your way to discredit this.
No, I didn't go out of the way to discredit. I went out of the way to try to test your hypothesis, and my experiment happened to disprove your hypothesis.
Well, it's not my experiment. It's the experiment that everyone that's bothered to do it gets the same result except for you. But hold on, do you remember?
No, not except for me. Everyone that's done the experiment properly gets the same results as me.
Do you remember your friend Sean Hudford when he lied?
Don't call him my friend.
Well, the guy you associate with,
I don't associate with him.
You did. He was on your show when I
used to. I used to, but I do not have anything to do with that person anymore.
Well, he's a liar because he was pretending he'd done it during the full moon, and then I saw on his video the date because he had a timestamp, and I said that was before the full moon, and I caught him out lying.
His video actually had the full moon in it, but anyway, Sean Hufford isn't me. I don't care what Sean Hufford did. It's completely irrelevant to the fact that my experiment disproved your hypothesis.
Well, not when I did it, and not when a lot of people I know have done it.
You didn't do it properly, Howard. In fact, you've never done it.
I've done it twice.
No, you haven't.
I just don't want to do it on video because...
No, you haven't. You've never done it. You've never recorded any data. I recorded a month-long data, pictures, videos, every single day. I've actually done the experiment. Yes, there absolutely is. There absolutely is a reason to do it every day for a month because you need to see if the moon is actually the reason for the reduction in temperature. So you do it every day of the month. You do it every phase. You do it whether there's clouds. You do it every single day, and you then compare the results over the month and see if when the moon is out, that's what causes a reduction in the temperature. That's how to do the experiment properly.
You know, a sundial is a vertical column that can give shade, and the shade moves depending
Sundial isn't vertical.
You know how a sundial provides shade depending where the sun is?
I mean, it makes a shadow.
Right. So that shadow can be made with moonlight as well. So a vertical wall can provide shade for an hour or two, and you leave a glass on the other side of the wall, and it's not in the shade, is it?
Yeah, I did that.
After 1 or 2,
That's what I did. I did that every day for a month.
Please stop interrupting me. After 1 or 2 hours, you can try that one that was in the shade, that's now in the moonlight, and this one that was in the moonlight is now in the shade because the shadow moves.
Yeah, I did that every day for a month. That's what I did. I did that every day for a month to test the hypothesis every day for a month. Because in science, you have to repeat the experiment. You have to try and remove variables. So the variable I tried to remove was the moon. And whether the moon was whether the moon was there or not, the thing in the shade, the thing being covered.
No, that's what I'm saying.
The difference between hold on. Let me finish. Let me finish. Right, Howard, I'm talking. Howard, I'm talking. Let me finish.
If
Howard,
there's no moon, there's no
Howard,
shade. What are you talking about?
I'm talking. Let me finish.
You're talking rubbish.
Howard, I'm talking. Let me finish.
Rubbish.
Howard, I'm talking. Let me finish.
Rubbish.
Right, Howard, you haven't even listened to what I'm trying to say. Right,
you do it over 2 years ago when you were talking about it, and you're talking
Howard,
shit.
Whether the moon is there or not, you compare the difference in the thing that is covered to the thing that is not, to see if there is oh my God! Will you shut up and let me finish?
Yeah, go on, and then afterwards I'll prove why.
When I say covered, I just mean the thing that is, where the moonlight would be, the thing that's being blocked. Even if the moonlight isn't there, right? You have something that is covered and something that is not. Something in the shade, something in the moonlight. And you have the same thing set up every day for a month, whether the moon's in the sky or not. And you test the difference in the temperature between the two bits of water to determine if it is the moon that is causing the water to cool. And it is not. You find that over the month, the difference in the temperature between the waters stays average, whether the moon is there or not, and regardless of the phase.
That's false, and you know it. You're lying.
It's not false. I provided the data, the entire experiment, a month long.
Flawed. You've just said that
nothing in it was flawed. Nothing in it was flawed. Your understanding of science is extremely flawed.
You've just said it was covered and in the shade. In the shade from what? If there's no moon.
The thing that would be. Yeah, you didn't listen to a fucking word I said. I said the thing that would... No, you didn't. 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 Because you would have listened and understood that I said whether the moon is there or not, the moon that would be creating the shade, you have the same setup whether the moon is there or not.
You said covered.
Yeah, and then I explained, literally, not covered over the top, something that is blocking from where the moonlight would be. That is what I refer to as covered. It's not got something covered over the top. It is the setup that you described, just a month-long version of it, and it disproved your hypothesis. All right? Next question. Yes, it does. Next question. Sure. Next question. It disproved your hypothesis. It disproved your hypothesis. End of story. It disproved your hypothesis. It disproved your hypothesis. End of story. It disproved your hypothesis. End of story. Shut up. Hey, dipshit, shut the fuck up, alright? I'm not lying. I did the experiment. You have never done the experiment in your life.
I've done it twice.
No, you haven't. You've never done it. You're lying. You're lying unless you can present the data.
No, you're telling people to trust your results.
No, I'm not. People did the experiment with me. It wasn't just my results. It was hundreds of people's.
Bullshit. 5 years I've been telling people to do it for themselves. And
they did do it themselves. They did the experiment with me, you dipshit.
No, you and a few of your minions.
Hundreds of people. Hundreds of people.
Yeah, bullshit, Craig.
Yeah, that's all you've got is claiming stuff and his lies. That's all you've got, Howard, because you're a fucking idiot. Right, Takis Yanis for 2014. Shut up. Shut up. Takis Yanis for... I'm asking you to be quiet now, thank you very much. Takis Yanis for Thank you.
Liar.
Takis Yanis for 2048 huffs. I would like to see a Flurf who rage joins before the agreed start time. Yeah, that doesn't work. Don't call me a liar. I never lie. I did the experiment. You never have.
Lie.
You've never done
Don't
the
lie.
experiment, therefore you're a liar.
You're a liar, Craig.
No, I did the experiment and people did it with me, therefore I'm not a liar.
You did it wrong on purpose.
No, I didn't.
to
I
discourage
did the experiment
people.
exactly as it should have been done. Not my fault that you don't know how science works. Delhi...
Liar.
No, I'm not a liar. You're the liar because you've never done the experiment.
Oh,
Delhi
yeah,
one...
okay.
Don't call me a liar again.
Same
Don't call me a liar. Shut your fucking mouth. I did not lie. I did the experiment. You have never done the experiment. So don't lie and tell me you've done the... No, don't lie and tell me you've done the experiment when you've never done it. You have never done the experiment, all right? You have never done the experiment, ever, ever, ever. You are a liar.
Is this to convince? Is this to convince
No. If you'd done the experiment, you would have presented the evidence.
Is that how you convince people that you're telling the truth?
I did the experiment and people did it with me. I did the experiment and people did it with me.
All the time?
I did the experiment and people did it with me. Therefore, I'm not lying.
Maybe people
You've never
believe
done
me
the
if I keep
experiment.
doing this.
You've never done... hold on. 1 second.
Yeah?
One
You're full of
second.
shit, Craig.
1 second.
Every time you lie, you do this. Yeah? You want to convince people, so you do this.
Let me show you something, Howard. Let me show you something.
What, that you did the experiment with shitty conditions to try and discredit
No, I did the experiment
and-
every day for a month, regardless of the conditions,
Why?
Howard.
When it's only during the full moon and a few days after the full moon that it gives a chilling effect. Why would you do it any other time?
To show that it's not just a chilling effect during those times.
That's the only time it chills. So why would you need
So
to
I did it for a whole
exchange-
month to disprove that hypothesis, to show that the
there's-
reduction in temperature happens regardless of the phase of the moon.
You're full of shit, Craig.
So you can say I'm full of shit. However, Howard, how many times have you done the 666 symbol tonight, do you think?
Oh, when I'm copying you.
No, this isn't when you're copying me. This is just at a random time. Look at that. Look at you there doing the 666 symbol while you're talking to me.
That was copying you, mate.
No, it wasn't.
Yeah, it was.
No, it wasn't,
You're lying
Howard.
again, Craig.
No, it wasn't, Howard.
Craig.
That is a screenshot
Craig.
that someone took during your rant. Nothing to do with me.
Yeah, because I was showing.
Look at
people that
you! Look at you doing the
you were
666 symbol,
convincing.
Howard. Look at you doing the 666 symbol. You fucking Satanist.
It's how you convince people. It's how Trump convinced a lot of people, innit? It's called a mudra.
Sorry, what's that?
You use whatever you need to, mate, but a lot of people are waking up that you're full of shit.
Yeah, except the people that did the experiment with me. No one thinks I'm full of shit apart from fucking morons like you that don't understand science and only do an experiment during the time that they think the thing would be happening instead of when they think it wouldn't be happening to try and compare the results because they don't understand how science works.
You can compare moonlight to shade of the moon that night. You can't compare
and then you
moonlight
compare it
shade of the moon.
then you compare it to the conditions every other day, you fucking dipshit. Did your parents meet at a family reunion?
When the moon is above
Yes,
you
they
in the
did, didn't they?
time,
Your parents met at a family reunion, didn't they, Howard? Howard, everyone who has ever loved you
you're full of
was
shit.
wrong. Everyone that's ever
Oh,
loved
you're
you
doing it
was
again,
wrong.
Craig. You're doing it again.
Everyone that's ever loved you was wrong.
Yeah?
Yes. So, Delhi has been a member for
Really
4
funny.
months,
It
says,
doesn't prove that
ask
you're
him
not
why
alive.
you can't see Polaris below the equator. He's already admitted he doesn't know that. Eon Dust for $5 Australian. Hey, Howard, baby. Done
Actually,
fights test yet?
I'd like to answer that question. It was
No,
a good
you can't.
question.
I'm not letting you. Hey, Howard,
It was
baby.
a good question. It was a good question.
Yeah, I'll mute
great
you.
question.
Right, you're muted until I want you to answer a question. You can run away if you want. So, Howard, have you done fights test yet? The one where you put moonlight in the shade for a whole month to see which moon faces cool water? Right, please answer that question, Howard.
You can't see Polaris when you go outside of the
Yeah,
equator.
no, that's not the one I asked you to answer.
It's a good question. I'd prefer to answer that
You
one.
already tried to answer that earlier, so I'm just going to ask you this one instead.
No matter what shape Earth is, when you get far away, things in the distance.
Yeah, so you're muted until you agree to answer my question. Just do that to agree to you're going to answer my question. Just let me know. Just do that to say you're going to answer my question, and I'll unmute you. No one can hear you right now, Howard. Just do that, and I'll let you know that you agree to answer the question that I'm going to ask of you. Go on. Just do that again. Right, thank you very much for doing that. Okay, So you're unmuted now. So the question, Howard, was have you done the moonlight experiment where you put it in shade for a whole month to see which moon phases call it? Have you done that?
The moon is above you in the daytime during a new moon.
So the answer is no. Lovely. Okay. Donald Trump's Bone Spurs became a new member. Welcome to Scrappers. Thank you very much. Lord Luminous Pooh for $5 says, has he gish galloped over the horizon into the settings? Yeah, that's the goalposts went with him, honestly. Mr. E-Man for $9.81 Australian, because gravity always wins. Yeah, no flat earther can disprove gravity, ever. Alison for $2 Australian.
Proven gravity.
Yeah,
Have you ever proven gravity?
I've personally measured it, yes.
You've measured the speed of momentum of something falling?
I've measured gravity. I've measured the attractive force created by gravity.
Really?
Yes. Not
What
hard.
is your Nobel Prize?
Sorry, it's done by every single first-year physics student.
Oh, so you've measured how quick things fall, or you?
No, I measured the attractive force between two objects and personally calculated the gravitational constant from my results.
Wow.
Yeah, it's not hard. In fact, I've got two friends, Blue Marble Science and BM Furball, who also did the same thing on YouTube, including building the experiment live. It's something that's done all of the time, Howard. Literally, every single physics student who's doing a degree, this is like within the first 3 months, they're doing an experiment to measure gravity.
Yeah? How does that work, Craig?
You get a torsion bar, hang it on a wire, have masses on one end, on both ends, and introduce a larger mass to it to see if the attractive force is as we expect it to be.
This is that.
My particular group, when they did the Cavendish experiments, split into 12 groups, and between us did it in different places with different materials, different sizes, different temperatures, different pressures, including one doing it in a vacuum. So we all independently measured the attractive force between two objects and calculated the gravitational constant, and we all got exactly the same thing, even though we all use different materials, different pressures, different sizes and stuff. So, you know, science, baby.
Conclusions, maybe.
Yeah, well, the conclusion, that's step 5 of the scientific method. You analyze your results. So after we've done the experiment and we analyze our results, all the results showed that there was an attractive force between masses that allowed us to calculate the gravitational constant, which agreed with what it actually is. So, you know, science, baby. Mr. E-Man, no, read that one. Alison for $2 Australian says, these cows are far away, Howard. Yeah, stars really far away, parallax very small. Deli1 for $2 says, what is the farthest visible star?
Make your mind up, Craig. Is it too far away to notice, or is it clearly changing that the constellations have had to change in the last few decades, and Polaris didn't used to be in line with the Georgia Stone's peephole? Make your mind up, Craig.
Well, again, I said both the same things. You know, they don't. The amount of change is so small that thousands of years ago they would have relatively been in the same place. I've not contradicted myself at all.
Just in the 80s, the peephole wasn't looking at Polaris, but now it is looking at Polaris.
Well, it's still not looking straight at Polaris. It's still slightly off center, but it has shifted a few arc seconds. Yes.
Bullshit, Craig. You follow that.
Measurements aren't bullshit, Howard. Your denial is fucking hilarious.
Your hearsay is
hilarious.
Hearsay.
Evidence isn't hearsay. Evidence isn't hearsay just because you don't like it. Anyway, Deli1.
Stone carved.
Yeah, I already answered that, so please stop going. I'm trying to read a super chat. Can you stop talking? Thank you. You're muted right now. Stopped. Right, thank you. Yeah, we went over that. The carvings don't disagree with all the almanacs and stuff that we have. So anyway,
yeah, they do.
No, they really don't. They really don't. Deli1 who asks what the furthest visible star. No, they really don't. No matter what you say. Ask what the furthest.
No matter what you say.
No, they don't. I have explained why they don't. No matter what you say, they still don't. Deli1 asks what the furthest visible star is. I'm not sure. I honestly have no answer for that. I'm sorry. Alison for $2 Australian says, $100 telescope is enough to observe parallax. Yes, it absolutely is. Mr. QTube, first name Fa for $5. There's no stellar parallax in his opinion. Since when does science care about his opinion? Not even his family care about his opinions.
Can
Mike
you
Hurdy
show
for
me any
£10.
evidence?
I've shown you plenty of evidence. Mike Hardy for £10 says...
talked about it. You talked about it. Can you show me some?
mctoon.net/Polaris. The evidence is there. Go ahead and find it yourself.
Pull it up. Let's see it now. Let's all see that evidence now.
Okay, I'm talking right now. mctoon.net/Polaris. Anyone can go there. Mike Heady for £10 says, I'm on a night shift and this is keeping me occupied. Good job winning another debate. For your information, my new debunking channel is nearly up and running. Just need to find a Flurfa video to debunk. Daniel Pratt's doing some good stuff right now. When I say good, I mean fun to debunk. Lord Luna's Proof, $2 says, yay, coffee. Now I'm sleepy and anxious. Fine Media has been a member for 9 months, says, science is wrong. 2,000-year-old stone tablet is right. Top left contender for sure. Yeah, but the stone tablet doesn't disagree with science, which is, nice. Alison for $2 Australian says, sextants would have been great to bring up here. Next time Howard and I talk, we're going to talk about sextants, aren't we, Howard?
We can talk more about the pendulum as well.
Yeah, because the pendulum destroys the flat Earth dead. No, absolutely 100%. It kills it. There is no rebuttal to the pendulum. It's just, it kills flat Earth dead. End of story.
There's loads.
Sorry?
We'll get into it next time, Craig.
But there is literally zero rebuttal to the
Are
pendulum.
you sure about that?
Absolutely 100%, yeah. There is no rebuttal to the pendulum that can disprove it. There is simply none. Flat Earthers may misunderstand it and strawman it, but there is simply zero rebuttal to the pendulum and how it measures the Earth's rotation and verifies that the Earth is a sphere. It's a fact. It can be repeated by anyone ever, and there is no Flat Earth answer for it. It kills the Flat Earth dead. We'll talk about that next week.
Sure thing.
Jeffy Combs, $3.33. Does Howard have a working model for his side? Of course he doesn't. Flat Earthers don't have models.
I'm not a flat earther, but if you'd like to see a working model,
I mean,
look at a torus field.
That's not a model.
Yeah, it is.
No, that's not a model.
That's what we understand.
No, that's not a model.
Yes, it is.
No. There is not a model. Please look up what a scientific model is. Thank you. Tim Tully's been a member for 11 months, says, do you call yourself a globe skeptic because you don't have to give positive evidence for your position and you can't be questioned?
I can show what a magnetic field looks like, which we assume an atom looks like. So why would our atmosphere...
No, a magnetic field looks nothing like an atom. That's fucking nonsense. Please answer the question that was just asked of you.
Have you ever seen an atom, Craig? Have you ever seen an atom?
Yes.
Really?
Mm-hmm. Electron microscopes are amazing things. So Tim Tully asked, do you call yourself a globe skeptic? Yeah, so Tim Tully says, do you call yourself a globe skeptic because you don't have to give positive evidence to support your position?
Where's your positive evidence? All you've shown me is
pendulum
models, cartoon models and graphics.
Yeah. So, all right, you're ignoring the question. That's fine. Yeah, I've got plenty of positive evidence. You have nothing. Selexus for £5 says, please have me explain why yin-yang symbols prove the flat Earth.
Because if you put the yin-yang symbol into a fourth dimensional shape, that's probably more like what Earth is than flat or a ball.
Yeah, that was a lot of nonsense. So you agree it proves flat Earth, so you're a flat earther. Right, brilliant. Paradimbu for $10 says, ask him to explain why the tropics of both Capricorn and Cancer are nearly the same circumference and the equator is larger than either of the tropics. This is only possible in a spherical object.
How come the analemma shows a bigger...
Oh, so you're just going to ignore every question that's asked to you, are you?
I'm trying to counter that argument with a
No.
argument.
It wasn't an argument. It was a question.
Yeah, and my question is, I can throw the same logic at why does an analemma show a bigger circle in the southern hemisphere than in the northern hemisphere? That doesn't work on a globe either.
It absolutely works on a globe because of the tilt of Earth. So, once again, you make a straw man by saying it doesn't work on a globe when it absolutely does. Brilliant. Salaxis for £5 says, Howard, caveman drawings are basic shapes. Does that make modern art non-existent?
No matter where you are in the Earth, the analemma will show a bigger...
All right, I'm going to mute you because you're refusing to answer questions. I'll unmute you when I've got another question for you. Eon Dusk for $10 Australian. Howard, Serious question. Is your real goal just to frustrate people for your own pleasure? I ask this because every time someone gets frustrated with you, your smile goes ear to ear. It's not frustration. It's just displaying a talking monkey to people. But you can answer that, Howard. I will unmute you.
Right,
No, he
that
doesn't.
picture off the screen.
No, that's a picture of you.
Well, this is the thing, you see, Craig. If you can't have a discussion with maturity and that
Maturity, you fucking deny everything like a little child. You are the absolute opposite of maturity, Howard. So shut your fucking mouth, you dipshit. Right, S. Aston for £5 says, how can an all-powerful deity's message be questioned and refuted and still be worshipped as all-knowing truth? I think that was to me. I don't know. Sorry. You're going to stop doing the 666 symbol, Howard? That's a bit rude. Tommy Granville for 20 Nokia says, not so much as skeptic as total denialist. Yeah, you aren't a skeptic, you are a denialist. That is a fact. You are a flat earther, Howard, whether you admit it or not. Alison for $2 Australian. Howard, why is all navigation based on a globe?
Why are you so immature and you got to ridicule? Why can't you actually have a normal conversation? Is it because
you can't have normal conversations with children like you?
I'm not a child, mate. You're
you most certainly are. The way you have acted today has been extremely immature. And the fact you can't see it just goes to prove that point. But anyway, Howard, Alison asks for $2 Australian. Why is all navigation based on a globe?
If you really think that you're the one that's acting mature by...
Yeah, no, so Howard, the question is, why is all navigation based on a globe, you dipshit?
Shushing me, muting me...
Yeah, Howard, so the question is, why is all navigation based on a globe?
Why isn't it?
It is. All navigation is based on a globe. This is just a fact. Why is that the case?
No, it isn't. No, it isn't.
It absolutely is. Celestial navigation, based on a globe. Pilots planning their routes, based on a globe. Why is it all based on a globe?
It's not, Craig.
Sorry, the Haversine formula very much disagrees with you. When you're planning your routes on a globe, you use the Haversine formula, which is based on the globe. So the fact that you use the Haversine formula for navigation shows that navigation is based on a globe. Plus celestial navigation literally only works on a globe. Why is that?
When they calculate distances and they're going to go in boats, they don't calculate with curvature.
Yes, they do. They use the Haversine formula.
Look, mate. You just keep talking.
As a sailor, as someone who is in the Royal Navy and actually had to do these calculations, I can tell you for a fact they use the Haversine formula.
I've heard differently.
From who?
From many people, Craig.
Yeah, okay. Well, I actually did it myself. So you use the Haversine formula. That is a fact. Therefore, navigation is based on the globe. Plus, celestial navigation is 100% based on the globe, simply because of the maths involved to actually do what you do. We can go over celestial navigation next week, though. It's going to fucking kill the flat Earth. The Rabbit for $5 says, does anyone else hear the Flurf saying quack quack? A flat earther that hates being called a flat earther. Yeah, I know. Serial 510, $2. Flurf, how long did it take to get a PhD in nuh-uh? You don't need to answer that.
I haven't said nuh-uh to anything.
You've said nuh-uh so many times tonight.
I think I've been quite mature. I think
no, you
I've been
haven't. You think you've been mature? Fucking brilliant. Anyway, OMG for 50 secs says the same. I'm still talking. So
I'm not coming back on this show, mate, if I can't get a word in.
You've got plenty of words in.
I've tried to be honest and give an honest answer when I don't know. I've tried to give alternative reasoning. I've tried to explain why people... Look, you're doing it now, Craig. I've tried to explain why people like me might not be convinced by what you believe.
Ignorance. I don't have beliefs. Do not say I have beliefs. I've asked you that.
Look, don't keep calling me ignorant. That's rude.
No. Again, ignorance isn't a nasty word. Calling you ignorant isn't an insult. You are ignorant of physics and maths. That's not an insult. It's just a fact.
No, I'm not. I'm just not convinced by your beliefs.
No, Howard, you are ignorant of physics and maths. That is a fact. You do not know physics and maths. Therefore, you are ignorant of those things. But that's not an insult, and it's not a nasty thing. I'm not calling you a name by saying you're ignorant of these things. I'm ignorant of a bunch of stuff that I really don't care about. I'm ignorant of
Like
who's
the-
in.
like the fact that-
I'm
like the
ignorant
fact
of
that you
who's in
have
the top
belief.
10 in the charts right now. I've no fucking idea. But I am not ignorant of science. I am not ignorant of physics. I am not ignorant of maths. You are.
Whatever, Craig.
So OMG for 50 secs says the same as always. Flurf can't understand scale, distance, and size. You need to carve your answer in stone, then he will understand. Debonk 179.
Ask your subscribers why they have to keep resorting to name calling like you. Is it because they don't actually have any evidence of themselves?
They're not called, no one's calling you a name. They're using descriptions. So chill.
Yeah.
Debonk 179 says, "How do you explain
this?
this?"
It's all ridicule. It's all pathetic. It's been going on for years.
Yeah, because flat Earth is ripe for ridicule. Flat Earthers deserve.
I'm not a flat
saying that,
earther.
but you really are. You literally admitted
I'm
earlier
not.
that you were a flat
The fact
earther.
that if you keep resorting to calling me a flat earther, then you can fuck yourself. I'm not coming back on your show.
Dude, I asked you a question earlier, and you said the response was, basically saying that the Earth is flat. You can say you're not a flat earther, but a globe skeptic is just a flat earther by another name.
No, it isn't, mate.
It really is.
Craig, from the very first time I appeared on your show 4 or 5 years ago,
I've not been on YouTube that long.
I'm not a flat earther. I said Earth could be multi-dimensional. And in every single appearance I've ever made on a debate show anywhere, I've always said I'm not stuck to 3D. It could be 4, 5, 6, 7, who knows? So, if you can't get your head around that,
so I mean, all the evidence you try and present, all the things that you say are flat Earth arguments, Howard. All right?
No, then
no, they really are. And again, this isn't an insult, right? This is just a fact. You are, by all intents and purposes, a flat Earther by another name.
No, I'm not, mate.
I mean, you can deny it, but the evidence stands for itself.
I don't believe the Earth is flat because there's problems.
You really do.
Conundrums with the
Killer
flat Earth
Cuts
model.
asked
No,
for
I
my
don't.
email.
No, I don't. Why don't you get it through your thick skull? You're being rude.
You think the Earth is flat? It's fine.
Calling me a name that I'm clearly not, and I've
you are a flat earther, Howard, and I'm not going to lie to people.
5 years, I've been telling people I'm not a flat earther, yet you keep resorting to name calling because you lack evidence for your globe.
No, I've presented plenty of evidence. You've just denied it.
So you make the argument, you make red herring arguments to discredit me as a person.
No, I don't. I'm sorry, Howard. Again, you are simply a flat earther by another name. That's it. Flat earther is just a general science denier.
You don't have enough evidence to support your globe model.
No, I have plenty of evidence. I have plenty of evidence, and you just ignore it. So that's fine. Anyway,
ridicule, name calling, talking.
Anyway, so Killer Cuts asked what my email is. It's fighttheflatearth@gmail.com. Oh, I just skipped there. Debonk for 179 says, Howard, how do you explain the South Celestial Pole? He answered that earlier. Well, attempted to.
Yeah, good conundrum. That's why I'm not a flat earther.
Yeah, okay, flat earther. Fang Media for $5 says, Howard is just as stupid as a certain duck of the same name. Potter1408 says for $5, has Howard figured out why he can't see London in France yet?
Yeah. And I've answered this one a million times.
This made me laugh a lot. You thought that bit on the right was England, didn't you?
Well, when you search for UK from space, you get this picture, so I was assuming that they were classing that as the UK, an island.
But that looks nothing like the UK.
Shut up a second.
But it looks nothing like the UK.
Even Mr. Sensible made the same mistake and said he could see Ireland. So even Mr. Sensible made the same mistake.
You can see Ireland. It's off to the left down here.
Can you see Ireland, Craig?
Yeah, you can see like the top of Ireland on the right there. On the left, sorry.
So you can see Ireland, can you, Craig?
Can you not see where Ireland is? Just off to the side of the island on the left.
I'm talking about Ireland, northern and southern Ireland.
You can't see. You can just see the southern bit of Ireland off to the left of the British Isles here. You can see Wales, and then you can see a bit of light, and then you can see the bottom of Ireland.
Can you point out where Ireland is in this picture, Craig?
I just did. I guess you weren't paying attention. Anyway.
No, because ideally I'm looking at London, yeah? Sideways. So, where's Ireland, mate? Where's Ireland in that picture? And the point is... I just told you exactly where it is. You've got 2 ears. Maybe use them. Yeah, I don't think you're right. And even if I'm wrong...
Regardless of what you think, it doesn't change that I am.
This is my point. You're making the argument about my pattern recognition. I didn't recognise London was sideways. Wow.
Well, no, it's more the fact that you thought the coast of France was... I mean, did you really look at France there and think that tiny little peninsula was Wales? Seriously, Howard. How many times have you seen a map of the fucking UK and you would look at that and think that tiny little peninsula on the north of France was fucking Wales? Like, it took me a while to realise how dumb you were being about this picture.
Mr. Sensible made the same mistake. Not that it matters, because my point is there are no photos of a whole country that you can backdate for a few years.
There literally is.
Because you're full of shit.
You can say that, but people literally showed it to you on Twitter the next day and you ignored it.
Yeah, and some have got clouds, some haven't. Some have got curvature, some haven't. They're all inconsistent because there are
Of course some are going to have clouds and some aren't because they've done it different times, you fucking talking monkey.
Keep insulting me because you lack evidence.
That wasn't an insult, that was a description of you. You are a talking monkey.
And you are a child that can't find real evidence to support
I have presented evidence and you denied it.
Cartoons, calculations, and ridicule.
Scientific experiments are none of those things.
Red herrings that make the argument.
Scientific experiments measuring the rotation of Earth debunks you.
No, your say-so doesn't debunk shit.
No, sorry. The experiment that can be repeated and is done all over the world that measures the rotation of Earth debunks you.
How about the observation? No, rotation of the firmament, maybe. Rotation of
there is no way a pendulum could pick up the rotation of a firmament.
Really?
Yes, absolutely. Really? You can do it inside a building where it can't even see the well, it is done inside buildings. You can't even see the sky, and regardless of the material that it's used in, that you use to do the experiment, you still get the same results. There is nothing that the firmament could put out that could make the drift of a pendulum while swinging correlate to your latitude on Earth.
Yeah, there is, and also if it's
what is there? What is there? What could do it?
Forces.
Like what force?
You said forces.
What forces? What forces?
Momentum, same as the pendulum would
what forces? Yeah? And you said momentum.
What forces are you talking about?
Coriolis force.
Same forces.
No, so you think that a firmament rotating above you could cause a Coriolis force?
Or the sun? Maybe the sun goes
none of those things could cause a Coriolis force.
How do you know?
Because a Coriolis force is a direct result of being on a rotating body.
Or could it be in a rotating
No, it's on a rotating body. That's what physics says a Coriolis force is. You cannot redefine Coriolis force.
Yes, you can, because science is about redefining things until they get understood.
Coriolis force is something that is defined. There is a law about it, all right? It is a specific reaction to being on a rotating body. It's a literal result of conservation of momentum. It is nothing that could be affected by something that isn't touching it.
Yeah, well, if we're in a magnetic field and there's a
magnets couldn't do it. Magnets couldn't do it. Magnets could not do it.
Fuck off! If you're not going to let me speak. Bollocks. I'm done with you, Craig.
You said magnetism, but magnets couldn't do it, Howard, right?
You didn't say magnetism, dickhead.
You just said magnetism. Right, go on then. What force? Go on.
Right, you're on about the conservation of momentum, yeah?
Yes.
Thank you. So if there's a conservation of the sun's momentum for millennia, and maybe that's affecting forces. Go on.
That's not what conservation of momentum is. Conservation of momentum is something that applies to something within a reference frame. It's conserving it's conserving the momentum that it gains from being on a rotating surface. The conservation hold on, let me finish. Conservation of momentum isn't something that can be.
You didn't let me finish, Craig. You didn't let me finish. You interrupted me and changed.
You just asked me to explain that. So conservation of momentum is not something that can be imparted by something far away rotating. You know, the sun's momentum, however far away it is, could not affect a pendulum. That is not how conservation of momentum works. Conservation of momentum is because that's not what conservation of momentum is. Conservation of momentum is
you don't know what the sun is. You don't know what Earth is. We're in Earth's magnetic field. Now let me talk. We're in a magnetic field. Yes. Correct?
Yes.
We're in a magnetic field. Thank you. Right. So if the Earth is stationary and the sun is in our atmosphere, then everything in this Earth's magnetic field, everything in this atmosphere would be affected by the momentum of something that's in this magnetic field that creates forces, heat, light, and God knows what else, vitamin D.
That's not how forces work. That's not how magnetism works. That's not what
are you on the dark side, Craig? You know all about the force, yeah? You know all about the force. There's nothing, forces that you don't understand, like dark matter.
Nothing you said there makes any sense at all.
Because I'm trying to explain something that we don't understand.
We understand magnetism. We understand electromagnetic fields.
I didn't say it was magnetism. I said we're in Earth's electromagnetic field.
Yeah, and that couldn't make any effect.
If that sun isn't far away, if that sun isn't outside of our atmosphere, if that sun is part of our electromagnetic field, if not a source of different forces, then it could affect pendulums, couldn't it?
No, it couldn't, because the electromagnetic field being distorted would not affect the pendulums in any way.
I didn't say distorted. I'm saying that if there is a constant momentum, which there is, if it is inside our atmosphere, which
that's not how conservation of momentum works. Conservation of momentum cannot be transferred from one thing to another through the medium of whatever, all right? You're talking about a magnetic field and ether and stuff. That would be an electromagnetic force that would be created, right? That is what the result of what you are trying to say would be, is an electromagnetic force. However, regardless of the material, you get the same result with a pendulum, meaning that it is not a result of any electromagnetic forces.
Everything in Earth is part of the electromagnetic field, yes or no?
Everything in Earth reacts differently to an electromagnetic field depending on its composition.
Yeah, but I'm not talking about magnetism. I'm talking about other forces that we might have not measured or manipulated.
What other forces?
Forces that we haven't been able to manipulate or measure yet.
Name a force specifically. What force are we talking about?
I've just said forces that we might not yet understand or been able to manipulate.
Like what? I mean, you're just making stuff up, whereas my prediction matches the forces that we expect to have.
I'm saying you're taking a reading and you're jumping to conclusions.
No, I'm not jumping to conclusions. I'm making a prediction or forming an experiment to test my prediction.
Yeah,
it's science, Howard. That's how science is done. You not understanding science and making up nonsense about conservation of momentum of the sun affecting the drift of a pendulum is complete and utter nonsense and pseudoscience. You do not understand. You do not understand what conservation of momentum is. End of story. Next question.
Actually,
are you kidding me? No. We're done with that. We're moving on. All right, we're done with that.
Yeah, because you don't like what I'm saying.
Because what you're saying makes absolutely zero sense. So, are you kidding me? For $4.99 says. Are you kidding me? Are you kidding me? For $4.99 says, I won't be surprised if Harold buys Fabulosos, thinking that it's fruit punch. I don't know what you mean there, but thank you very much. Lord Luminous Pooh, $2 says, I hereby accept fight into the Illuminati. That was supposed to be for personal communications. Crazy CJ123456 for $10 says, at this point I'm convinced with avoiding questions, his little dig insults, Howard is a Poe. He has to be. Don't platform this Poe anymore. He is not real. Oh, I enjoy platforming Howard because it gets to expose the stupidity. Tommy Gronfeld, 20 Nokias, says Howard showing the 666. Yes. This is an excellent picture. That will be a thumbnail. Logical Hillbilly for $5 says Howard is the thickster from Thickville. Ewan Grand has been a member for 12 months, says late as always, this will be fun. Oh yes, it was, don't worry. Mr. E-Man for $5 Australian. Howard says that the model does not agree with the observations that he makes, while the model shows the observations. Yes, absolutely it does. Average Joe, £20, thank you. Is Howie one of our pets now? Oh, let's drown it. Oi, don't you mean to pets? One thing I've got to give Howie credit on is his pet. The fact that he's got a 20-year-old cat is an impressive thing. And that is the one thing I will give Howie credit for, and even a little bit of respect, is that he's got a 20... Have you had that cat since it was a kitten?
Yeah.
Really? From a baby?
Yeah.
Okay, that's impressive, and I will give you respect for that. Keeping a cat alive for 20 years is amazing. What breed is she?
She's like a Siamese cross.
She is gorgeous. Absolutely gorgeous, Howie.
She is. And now listen, everyone out there, I'm not a flat earther. I'm not preaching beliefs. I'm not asking anyone to trust what I'm saying. I'm only trying to explain to people why there's a lot of skepticism, why there's a lot of people becoming flat earthers. And I'm only trying to encourage people to do a bit more primary observations and compare evidence, and to not resort to name calling, because even if people are wrong to think Earth's flat, and even if people are wrong to be skeptical about the globe or space exploration, there's no benefit shouting, swearing, calling each other names. It's been going on for years. It's not scientific. It's not a
Tell that to all the flat
method.
earthers.
It's not necessary. And if you guys really think you're right, you should be able to prove your point without all this ridicule and slander.
Oh, we do. The ridicule's just fun, honestly. Just out of interest, Harry, what are the 5 steps of the scientific method?
You're asking someone that's a bit dyslexic. If I remember right, you make an observation in nature. You make a hypothesis, you test the hypothesis, you draw a conclusion, and then you repeat the test. So
you missed one step there. It's very close, and I'll give you credit for that. So you make an observation, all right? Then you form a hypothesis as to the reason of that observation. Then you use your hypothesis to make a prediction. Then you form an experiment to test your prediction. Then you analyze your results. That's the 5 basic steps. So you were close, better than most flat earthers. Right, Fang Media for $5 says, can't use mind control on Howard, he doesn't have a mind to control. Needs to take a hit for every time this moron repeated himself. I need a bong, don't worry, it's coming soon. Folker Persia Pakashi, $2, your picture of Jupiter is overexposed, Howard. Ellie Merrily Kerlery for $2 Australian. Any news on Flat Out Hero? I heard he saw sense. No, he lied. And I've got a video coming up about him very soon. Free Life Taz for $10 Australian. All religious books say different things and contradict each other, whereas almanacs all match. Very bad analogy. Windbreaker, 50 Nokias. Yeah, go on.
Just a quick comment. The Bible has got lots of verses that match the Quran, and the Bible and the Quran both match the depictions carved in Egypt and the artifacts and many other places around the world. So yeah, I disagree. There's a lot of things that do match up.
I mean, they also have a hell of a lot of... I mean, the Bible contradicts itself from page to page, but, you know, to quote Professor Dave, a book says a thing. Windbreaker, 50 Nokias. Howard, do you live with your mum or do you have a caretaker? I believe you live on your own, don't you, Howard?
I live with my cat Smalley. Do you know what's weird about Professor Dave?
How awesome he is?
Not only did I notice he blocked me on Twitter a few years back when I pointed out that I took a screenshot of his Facebook page. Had like 100 or 200 followers, yet his YouTube had 1 million subscribers then. Now it's got 2 million supposedly.
Yeah, thanks to the video I did him recently. It was me that fucking pushed him over that 2 million mark.
Yeah. But what's really weird is when you go on YouTube and search for Flat Earth, instead of getting any serious videos from globe skeptics or flat earthers, the only person that you will see is Professor Dave, which is really weird.
And
because
the reason for that is simple, because he's got the biggest flat Earth video on the planet with 12.6 million views. So
really
it makes
weird.
sense that when you search flat Earth, that's what comes up.
It's really weird that YouTube gives you nothing but Professor Dave for the first 20-something videos, and then you get videos from you and videos from other people that are all like joking. It takes a while before you can see any serious videos about flat Earth or globe skepticism.
Yeah, it's very simple. It's because ours are more popular and it feeds the algorithm better.
Doesn't that say that there's a bit of shadow banning, a bit of censorship?
Not really. It shows that the algorithm favors people like us, and that YouTube doesn't promote conspiracy theories.
Yeah, so it's interesting. It's very interesting that Professor Dave is the only person you will see.
Well, not really. Like I just explained, it's because he's got the biggest videos. That's why. You understand that, right?
Isn't it weird that his Facebook page only had 200 or 300 likes about 1.5 years ago, when he supposedly had 1 million followers on?
Yeah, he doesn't
YouTube.
He's never used or promoted his Facebook really. So he does everything for YouTube.
But he could have fake subs on YouTube, and now he's trending to help him get real subs. Something weird going on there.
Everyone claims fake subs, but you know.
Very weird. Very weird.
Andres Eldritch 56. The Flurfer brain is quite fascinating. Only able to picture one dimension and resetting every few seconds. I love the Flurfer reset. Your pal Al, not Pal, my AI, a different pal Al. For $2 says the P900, the flat earther telescope of choice. Eon Dust, $5 Australian. I don't care about Saturn. Saturn's better, but I like Silk the best. Fogapesha Pakashi, $2. Howard is right. He's a denialist, not a flurf.
Skeptic.
Okay? Denialist, yeah.
If I was a denier, I wouldn't be here asking you to show me stronger evidence than what I've seen elsewhere.
But Howard, when I show you the evidence, you deny it.
I don't, nothing. I've been really honest and said, yeah, that's okay, that's not bad, this could be better, but I'd still think this. I've been really mature. It's a shame that your subscribers follow your footsteps instead of mine.
Oh, of course. Rune237 for $2. Watch out for those frequencies, Craig. Gross Petate for $2 Canadian says, Saturn is the devil, Bobby Butcher. William Foley, been a member for 26 months, says, got a light of Flurf, Harold is a right plonker. Fogger Persha Pakashi, $2. Howard, where is Rogers Stadium in that Toronto pic? And he says it should be right at the base of the CN Tower, but it's not there. And by your logic, the Argos are a swim team. Yeah, stuff underwater. Brilliant. William Foley, $9.99. This is an enjoyable dumpster fire of a debate. Unfortunately, I have formed the opinion that Howard is mentally ill. And all that jazz, £5. Joined a bit late just to walk into the same old bullshit, naturally. Thanks for joining. Alaskan John Bond for $5. Just finished a 16-hour day, truck driver in Alaska. Perfect way to end the day. Destruction of a flurf. Good job. 16 hours, truck driver in Alaska. Do you drive over the ice and stuff? Because that sounds fucking scary. Ellie Merrily Clarily for $5 Australian. Harold has gone full conspiratard. Never go full conspiratard. No, never go full conspiratard. Collapses $5. Hey Howard, if I had a super powerful telescope and I climb a really tall mountain, can I see you in Spain from here on the east coast of the US?
Say that again, sorry. Was that a serious question?
Yeah, he says if you had a really powerful telescope and climbed a really tall mountain, would he be able to see you in Spain from the east coast of the US?
No. Can I answer it properly?
Yes.
Right. As you said yourself, light will refract no matter what the shape of Earth. And that's because we have water vapor, we have pollution, we have dust particles, we have lots of things in the air, so air isn't actually transparent. So there is a limit to how far we can see even with the most powerful telescope. I believe it's a few hundred miles when we're land-based. But as my video clearly showed, we can see up to 4,000 kilometers away, 3,000 miles away. When we're above the clouds, we can see the Himalayan mountains from Dubai. So it's funny how that
Never seen that.
lapse rate work. That lapse rate seems to work out fine every time.
Yeah, because it's worse during the surface. So anyway, no, you can't.
No, I'm on about when you're in an aeroplane above Dubai, you can actually see the mountains of Everest, the Himalayan mountains, 4,000 kilometers away. I mean,
yeah, I've
how
never
much
seen that. So
should there be on that?
that's just something I've never seen evidence of. Anyway, Donald
It
Trump
was in my
bone spurs.
video. It's in my video. Well, I'll get it back up next time.
Donald Trump bone spurs been over for 28 months. Says YouTube broke an algorithm. I'm guessing 25 months. No, 28 months, dude. Excuse. That bong. Excuse me. Giant mutant ant has just become a member. Welcome to Scrappers. Yes, I'm dying. And then gave a 20-something dollars, not sure what that is, but thank you. Oh my god, he never shuts up, does he? Evidence clearly does not mean anything to him. Bishop of Hexen, 192, $5. You're literally telling the people who did the actual experiment and work that they are wrong, as you lazily sit back and do nothing, like all flirfs. Flat earthers in general don't like experiments. Pivot Croy for €20 says, Howard, in your moon experiment, the light from the moon is the IV and the temperature is the DV. Craig has proven that whether the IV is present or not has no significant effect on the DV. Therefore, your hypothesis is false.
A magnifying glass manipulates the chilling effect, which proves that the moon is the independent variable.
It does not. I've never seen evidence of that ever.
Well, try it.
Yeah, I have tried it. It literally doesn't. I bought a magnifying glass for that specific reason, and it made no difference whatsoever.
That's weird. There's people that have done it that I know have found it magnifies the effect.
Well, why have I never seen evidence of that anywhere? No videos, no comments, anything, ever.
Well, there's a video on the YouTube channel Truth is Stranger Than Fiction where he uses a big an old television screen as a magnifying glass because it's proper glass and it's big, so it catches a lot of moonlight and it magnifies it into this glass of water, and the glass of water goes about 2 or 3 degrees cooler than it was just being under the moonlight.
Did they do anything to demonstrate that it wasn't just doing that naturally, or no? Because I've literally done the experiment and it makes no difference.
Same as me, he left another glass of water outside, uncovered, but that was shaded from direct moonlight, and that didn't change in temperature at all.
Yeah, exactly what we expect from radiative cooling, yeah.
No, just like when Ken Al Wheeler showed different surface temperatures.
Yeah, Ken Wheeler, fuck's sake. Yeah, again, that is simply radiative cooling. It's physics.
No.
And Howard, this is why I'm not being nasty when I say it, but you're ignorant of physics. If you weren't ignorant of physics,
Craig,
you'd understand. No, you
with all
are,
due respect,
Howard,
with
sorry.
all due respect,
You are ignorant of physics. You haven't studied physics. You don't know anything about physics.
Bullshit, Craig. I know what radiative cooling is. I read it up 5-6 years ago and people use that excuse. So fuck you and you're calling me ignorant all the time. I know what radiative cooling is, and that would be because it's been covered by something that means the sun couldn't hit it, so it's not got as much...
no, it's nothing to do with the sun.
Right. The point is, if something's been sheltered... So
you don't know what radiative cooling is?
If something's sheltered, it would have less radiative cooling than something that isn't sheltered. But if they're both unsheltered, that means that they're not going to have different radiative cooling effects. If you put a book underneath the glasses of water to make sure the surface temperature isn't affecting it, you can do it in lots of ways, lots of controls.
Yeah, and when you do that, there's no difference.
The point is, if you compare the shaded water to water that's under direct moonlight, it'll go down in temperature. And if you use a magnifying glass...
Of course it will. That's radiative cooling.
The shade moves throughout the night like the shadow on a sundial moves around a sundial.
Yeah, it doesn't stop radiative cooling happening.
Look, radiative cooling would happen in both glasses if they're both unsheltered, uncovered.
And it does. If they're both uncovered, it absolutely does.
Right, so if they're both uncovered, like I've been saying for 5-6 years, but they both seem to, if one of them seems to go further down in temperature than the other because it's in moonlight, and then you check if
they're both uncovered, they're both in moonlight.
No, Craig, just like a sundial gives shadow on one side.
If it's not in the moonlight, it's in the shade.
Yeah,
right?
But it doesn't mean it's covered, does it?
Yeah, it doesn't have to be covered directly over the top for it to stop the radiative cooling.
So let's see if we can agree on this. A sundial, vertical stick, yeah? It gives shadow when the sun's on this side, here.
That's nothing to do with radiative cooling.
Exactly. There is no radiative difference. There's no difference in radiative cooling if both glasses are uncovered, unsheltered.
Yeah, and if both are uncovered and unsheltered, the temperature between them will still be the same.
Should be, but the one that's in moonlight will go cooler. And if you use a magnifying glass,
Howard, if they are both uncovered, then they are both in moonlight.
No, they're not.
Yes, they are. If one is in the shade, then it is not in the moonlight.
Stop talking and listen to what I'm saying.
Right, Howard, if it is not in the shade, it is in the moonlight. There is two options here. Shade or moonlight. That's it.
Shade does not mean sheltered, and it doesn't mean covered.
That's exactly what radiative cooling is. If there is shade, then it is radiating less heat out, because that shade means something is blocking the heat from escaping.
A sundial.
Yeah, a sundial has nothing to do with radiative cooling.
Listen to my point. For
your point is nonsense.
Your life, listen. A sundial doesn't cover or shelter any part of the sundial, does it? The stick that sits up.
Yes, it does. It creates shade. So the bit that's in the shade is covered from the light.
Yes, but it's not covered. It's not sheltered from the environment, from the atmosphere.
But it's sheltered from the light, isn't it?
Yeah.
Yes, exactly. So you're either sheltered from the light, i.e. in the shade, or you're in the light. Those are the two options. If you are in the light, you will radiate more heat than if you are in the shade.
Why? If they're both in the same garden, if they're both on the same surface, if the only thing that's different is that the shadow that's cast from a vertical column...
Yes, and that vertical column will be stopping some of the heat escaping, because heat just doesn't go straight... Heat, goes out in all directions, alright? But that bit that's making the shade, heat is not going to be able to be escaping and bouncing back towards the thing, meaning it'll be losing less heat. That's exactly what radiative cooling is. It's the difference between being in the shade or being in the light. If you are in the light, you listen. If you are in the light, then you are going to radiate more heat. Well, the moonlight, obviously, then you're going to radiate more heat than if you are in the shade. Whether that shade is directly above... Wait, I haven't finished. Whether that shade is directly above or it is vertical, it is still creating shelter that is going to stop some of the heat radiating.
Listen carefully. There's a vertical column, and there's a glass on this side and a glass on that side.
Yeah.
They're both listen, don't talk.
I said yes, I'm just agreeing, showing you that I'm listening.
There's a vertical column.
Yes.
There's a glass on this side.
Yes.
There's a glass on that side.
Yes.
One is shaded from the moon.
Yes.
One is in the moonlight.
Exactly. One is shaded.
Listen. The same column is next to both glasses.
Yes.
So if you're going to claim that this one vertical column that happens to be casting shadow here at the moment because the moon's over there, that would have the same radiative cooling as this glass. because they're both next to a column. But if the one that's in the moonlight chills for a few hours, but then the moon crosses the sky, and now this one's in the moonlight, and now that one's in the shade, do the experiment again, and guess what?
I did.
Hold on. The one that was in the shade, that didn't change temperature, now that one will go down in temperature. The one that was before in the moonlight, that's now in the shade because the moon's changed position, they're both next to a pillar. The one that didn't change now drops in temperature because it's in the moonlight, and the one that was in the moonlight that went down in temperature, now it doesn't change temperature. That one now stays the same. They're both next to a pillar. Neither of them are sheltered. Neither of them are covered. It's only the position of the moon that's changed. Listen.
Yes,
listen
the thing making the shade, right? The shade, Howard, the shade. The thing that's in the shade, meaning that it's in the shade, it's getting covered more, is not having the moonlight directly on it. It's in the shade, meaning it's not going to radiate as much heat.
Why wouldn't...
I just explained!
No, you haven't. They're both uncovered. They're both unsheltered. They're both
one is in the shade, one is not. The one in shade will radiate less heat than the one that is not. It's simple.
The moonlight chills water, and the magnifying glass
No, the moonlight doesn't
effect.
chill water because light cannot cool things. That violates the second law of thermodynamics. Radiative cooling is the answer you are looking for. Moving on.
Radiative cooling would matter if something was sheltered.
Radiative cooling is the answer you are looking for. Moving on.
Sheltered from the air.
Radiative cooling is the answer you are looking for. Moving on.
Stop shouting at me.
Yeah. Moving on. Howard, we're moving on. We're moving on.
That you depend
Howard,
on
we're moving on. We are moving on.
Because you're scared of what
Howard,
I'm saying.
no, I've answered your question. Not my fault you don't understand. I can explain it to you, but I can't understand it for you.
A magnifying glass amplifies the effect.
No, it doesn't. That's a direct lie.
Yes, it does.
Prove it.
You're a liar.
Prove it. Show any example ever where that has happened.
The only thing I can prove is to myself.
Because it doesn't happen. It's a lie.
Shut up a second. I'm sick and tired
of arguing.
I'm sick of arguing.
Yeah, then stop arguing with me.
Ask me a question, let me answer it.
I didn't ask you a question. You've answered the question. We've already done that. We can move on now.
You've challenged me to prove something. Let me answer it. The only thing I can prove... Shut up, Craig. The only thing I can prove is to myself. And that's all I've ever done. I've asked people to check for themselves.
So you can prove it to yourself when you're ignorant of physics, so you can't prove anything. Brilliant.
Please stop. If people check for themselves, then they can prove it to themselves.
Tim Pryor for $10 says, millions of people literally have jobs depending on gravity's existence. It's funny how these guys think it does not exist. Yeah. People's jobs literally depend on gravity.
If gravity exists, then it's a force pulling down. It's not a force pulling towards the centre.
Yes, it is. That's exactly what gravity shows. That's what I measured and calculated. That's exactly what it does. So, I mean, my experiment literally disproved what you just said. Any Cavendish experiment shows that the attractive force is between the centre of two objects. In fact, the attractive force is proportional to the mass of the two objects and inversely proportional to the square of the distance between them. That is easily demonstrable with an experiment that's repeated millions of times. Yeah. Mr. E-Man for $5 Australian says, why does Harold deflect rather than answer questions? Predicted response will be a deflection. Yeah, we're just going to... We all know the answer. We're going to move on from that. Beach 8, member for 28 months, says, stop censoring Harold, just mute him. I don't like using the mute button. Grimlock, $5, ask Howard to describe a four-dimensional shape.
Take a cube and add another axis, and you can only then draw the shadow of a four-dimensional
Okay, so if you took a cube, at what angle would every line be for the four-dimensional shape to the cube?
At a right angle.
90 degrees. Okay, yep, he's right. He did just describe a four-dimensional cube, but not with the shadow bit. The right angle bit is the important part.
Can you draw a fourth dimensional cube, Craig?
I don't think anyone can really draw a four-dimensional cube because a hypercube isn't perceivable with our brains. I can describe what one would be. Yeah, but the shadows wouldn't describe the shape exactly with 4 dimensions. I see what you're getting at, Harold. I do see what you're getting at there, but it doesn't quite work. Stick to the 90-degree at every point exclamation. That's a much better way to describe a 4-dimensional shape. It's a hard thing to do, but you did a very, very good job. Just try and ignore the shadow bit because it's very hard to correlate that to what our brains can perceive.
But that is what we perceive. If you see a drawing of a 3D cube on a piece of paper, that is what you call a shadow of a 3D cube, because you're not actually looking at a 3D cube, you're looking at a drawing of a 3D cube on a 2D paper. So it's a shadow of a 3D cube. Yeah,
it doesn't really translate when you're moving up dimensions because the shadows would be at different angles to the fourth dimensional. It's
the only way we can visualize it. We can't visualize it.
You're right. It's not something we can visualize. The best way to visualize it is just to try and imagine a 90-degree line to every edge of the cube at the same time. And that hurts my brain slightly. Anyway, the rabbit for $2 says, what is Howard's educational level?
GCSEs and not A level, but the A plus or whatever they called them.
The AS, I think it was.
Something like half an A level in English literature and something else, but that was 20 years ago.
Okay, I mean,
I've learned more in the School of Knox and doing my own investigations, my own experiments, and comparing results and listening to lectures.
I would seriously encourage you to study some physics, though. That would really help you with your investigations. Glober Mum for $10.
Experiments.
Yeah, but you have to understand the physics behind it, Howard, and that's important. Glober Mum for $10 says the Georgia Guidestones serve as a celestial clock of sorts. It contains a written message for humanity. Each axis is orientated towards specific areas of the moon's annual rotation around the Earth. Yeah, it's got a bunch of crazy shit on it, basically. Tim Pryor, $5, still claims he's not a flat earther whilst using flat earth arguments. See, when I call someone a flat earther, I'm not necessarily saying that they think the earth is flat. For me, it's a general term for people that don't know how science works. I guess maybe that's not right, but yeah. Molossus, yes, a tesseract, 4-dimensional cube. Mr. E-Man for $2 Australian. how at equals magic forces because I don't know. Yeah, there's no forces that could do what a pendulum does. Lord Luminous Pooh for $2 says looks like a Dubé, sounds like a Riley. It's a flurf. NA for $20. Howard, at no point in your rambling, incoherent response are you even close to anything that could be considered a rational thought. Everyone in this room is now dumber for having listened to it. I award you no points, and may God have mercy on your soul. Skycloud Observer for $2 says, I'm not a flat earther, from a flat earther. Here's the other thing, Howard, right? I've met a lot of flat earthers that say they aren't flat earthers, just because they don't like the negative connotations that flat earther holds. Right? So, when people say, I'm not a flat earther, but still use all of the flat earth arguments and talking points, you understand how it's hard to separate those things, right?
I feel like it's hard for people to acknowledge me as a globe skeptic because it makes them feel a little bit inadequate.
It would be easier to acknowledge you as a globe skeptic if you were just as skeptical about the flat earth, but you're not.
I am. I've just told you that I don't understand how the Southern Cross can go around a focal point no matter what part you look, which direction you're looking south.
Yeah, but when I asked you the question earlier, you said that you didn't have the same skepticism for flat earth as you do for the globe.
I'm saying that I see more logic in trusting my senses and the primary observations.
Man, your senses are shit.
Hold on. I've made primary observations with cameras looking at stars and planets. I've made experiments with thermometers and magnifying glasses on the moonlight. and I've made observations at water level, and I've made observations higher up than water level with cameras, and they all confirm what my senses tell me, that the horizon is horizontal, and it always rises to eye level, and that what we see is closer to the truth than what they show us on a computer and television screen. So I see more logic to the flat Earth theory and flat Earth model, although I'm pretty sure it's more than just a 3D shape or a 2D flat shape. I'm pretty sure Earth is higher dimensional than we are.
Okay, so PhD Tony, who is a Tony that has a PhD and actually works with gravity as his job, would like me to tell you that he had you muted for the entire debate, and as a result, he is now significantly smarter and better informed than before.
Funny, but that doesn't really prove gravity, does it?
I mean, his job proves gravity, really. What he does for a living proves gravity.
Does it?
Yeah, absolutely. I mean, people pay him a lot of money to work with gravity. So,
to work with forces, but
to work with gravity.
It wouldn't be called the theory of gravity if it was proven. So
why is music theory? Why is music? Hold on. Why is music theory a thing?
Because it's still something that they're coming to understand. They're still
No. I have a book called The Theory of Music, and in that book, it explains to me what harmonics are, what chords are, what octaves are, what the different notes on a stave are. It explains the concept of different timings. The theory of music contains all the knowledge that we know about music. It doesn't mean that music is a theory. Music isn't a theory by any stretch of the imagination, but there is music theory. There is the theory of music, but that contains all of our knowledge and understanding of music.
So far.
No, just it's all of it. But it doesn't mean that it's a theory, because in science, a theory is something that contains facts and knowledge and understanding and experiments and laws. A theory in science is the highest determination we can give to something that our understanding, points us towards. It's not the same. Hold on. It's not the same as the colloquial usage of the word theory. There is a marked difference between a theory and a scientific theory. That is why there is music theory. That is why there is the theory of gravity. It just contains all of our knowledge. That's it. Doesn't mean that it's a theory.
Knowledge that we've acquired so far, but we're still learning.
We're always learning. Of course we are.
Thank you. So it's a theory.
I'm pretty sure we know everything about music. I don't think there's anything new to learn about music.
Oh, there is. You should see what music does to water molecules and then freeze it into ice, and you'll see the difference.
Music cannot...
Look what rock music does to plants, and then look what Beethoven and Mozart does for plants' growth. Yeah, there's a lot of things we don't know about music and telepathy and dolphins.
So the theory of music is our knowledge of how music works, and like I said, it doesn't mean that it's a theory, just like the colloquial usage. Okay, nobody should ever say it's only a theory, because that's not what applies to science. A theory in science is the highest form of factual evidence that we have. That's it.
Yeah, but the theory of Newton's gravity was then surpassed
Newton never
by
had a theory.
Einstein's gravity theory.
Newton never had a theory, ever. Newton had a law. Newton gave us the law of gravity. He never had a theory.
But then they changed it, no? They've had to redefine it, no?
No, the law of gravity still works exactly as it always has. In fact, Einstein's 10 tensor equations for relativity, for gravity, break down in non-relativistic circumstances to Newton's law of gravity. You can literally derive one from the other because they are the same thing.
Really?
Yeah, absolutely. Tim Pryor. Wait, hold on. Excuse me. Jeffrey Hollenbeck for $5 says, Howard, can you give the kitty some deserved head pats, please?
With pleasure.
It's a gorgeous cat. I've got to give you that. I've got 4 cats myself. I've got my 2 girls that are 17, Esmeralda and Cookie. And I've got my 2-year-old black cat, Frisbee, and my little boy kitten, Dave. Here's a picture of Dave.
Hey, Dave.
Tim Pryor, $10. Did he just say air is not transparent? So pretty much he's saying we cannot see through air. Yeah, I'm done, lol. To be fair, I think his point was that air is slightly opaque. You know, air is transparent, but not 100%. You know, it over long distances, it does have a slight opaqueness to it. But, I mean, hydrogen gas is, you know, pretty clear to us up close. But then you look at Jupiter and Saturn and stuff, you know. I think that was his point there. Jimmy G, $2, Australian. Ignorance is bliss, and he's a happy motherfucker. Fog Repair Ship Akashi for $2. Flurf doesn't know words can have multiple meanings. Pivot Croy, 5 years. Howard, why add a new variable rather than just removing the moon from the experiment? You just add in more points of error. We can go over that more about the moon one next time. Mr. QTube, first name Fa for $5 says, I found out on Telltale Atheist channel that the Georgia Guidestones were made by a white supremacist. Yeah, they were made by some crazy fucker who wanted less than half a million people on the Earth. Fog Repair Ship Akashi, $2.
How come the government allow it to stand? How come the governments allow it to stand?
Because it's a historical monument, I guess. I don't know.
Or maybe because they're behind it.
I don't think they are. If they are, they did a terrible job at depopulation. Fog Repair Ship Akashi for $2. Howard, look up spatial disorientation. Our senses are shit. Yeah, Howard, our senses suck.
Which is why I used a camera, a thermometer, a magnifying glass, all to verify my senses. Yeah.
Anyway, right. It's been close to 5 hours we've been going, Howard. So look, I know it gets heated. That's just to be expected. Overall, I think it was a relatively good conversation tonight. Your cat is the winner, so let's just go with that, okay?
For once, we agree.
Thank you for coming on, and I hope I can get you back on so we can have some more talks, okay? All right.
Okay.
If you are truly just a globe skeptic, then you need to accept my evidence on face value, all right? And that's what we will talk about next time, because next time I want to present you some evidence of the Earth being a globe, and see your response to it, okay?
Fair enough. Maybe next week. If I can't, then the week after for sure. But yeah,
okay,
I'll be back.
All right, appreciate you taking your time. Speak to you soon.
Take care. Thanks, everyone.